So yeah, welcome everyone for day 2 of the training around Payara Micro and how to write cloud native microservices. Before I forget it, if you like to have a certificate of attendance, so that you'll add maybe for your employer, that you like to have that certificate that you were present here during these 2 days for the training, or as a personal souvenir, you can fill in this form. So by filling in this form, then you will get that certificate sent over to you, I guess, even this week. So that is one thing. Then let's have a look what I have planned for today. And then we go first with a review of that exercise that I briefly mentioned yesterday at the last minutes, because it was all we were actually a few minutes over time, but that's also a opportunity to have a recap of the first day of things that we covered there, CDI, JAVAPRO, and MicroProfile config. And then we continue with a definition, description, a few thoughts and ideas around microservices and Java in the cloud in general. And then we continue the microprofile specifications, and we mentioned that there were 8 in total. The config we covered yesterday, REST client, that is one topic that we will discuss a bit more in detail today. And yeah, the other microprofile specifications, I'm going to cover them also, but more briefly, just an overview of what you can expect, what you can do with them, and a very most of them, for most of them, a very small example, but not as extended as the config and the REST client, because those are the 2 most important, and the other one are also probably easier. Then we will cover a large block around data access. Every enterprise application probably needs to access some data. So we are going to look at the JPA specification, and especially then how you can configure a database connection within Payara Micro. And that's, of course, I'm going to show a little example of JPA, but the main takeaway there is that from that example, from that demo, is that some configuration aspects, how do you add, for instance, a JDBC driver, more about that post-boot command file, etc., that we briefly touched yesterday. As an alternative of JPA, I'm going to give a short introduction of MicroStream. That's, as mentioned yesterday, the sponsor of this training. So I'm going to briefly indicate why you, or when you can use it, why you should use it instead of a classic JPA solution, for example. Then the last large block is around integration testing, where I also cover a bit the Docker images, how to create Docker images for Payara Micro, because that integration testing will be based on the test containers framework, which makes use of that Docker framework. So that's another topic. And then not explicitly mentioned here, but there was, and if you have other questions, we can have them at the end of today, the 1 hour or 1 hour and a half even, to cover all kind of various topics, questions around Payara, microservices, Jakarta EE, MicroProfile, all the things that you still want to know about those topics. So maybe first a question, maybe you did not completely create the exercise that I mentioned about that shop where you can select bikes and cars, etc. But if maybe you started and you have some questions, remarks of what's went good, what was quite difficult, etc., and all those kind of things. So any kind of feedback that someone has around that topic, or maybe someone has created it and want to show it and briefly explain it, what he has done. So this is the, because I don't see any, anyone speaking up, so it's fine, of course, you can play it with later. As mentioned, you can find that in the repository under the labs. You have there the Jakarta one or the advanced one, where you have also a few things around security, but I'll cover briefly a better option of course, than writing something by hand as it's done in that example. The main contains the boilerplates for you, so that you only have to fill in, for instance, the JAXRS resource methods and implement the CDI beans, and within the solution branch, you can find the solution that I have created. So let's quickly go over that, that code. Then I can highlight again a few of the things that we have seen yesterday. And again, if you have then still some questions around one of the topics, what we have seen yesterday, then you have that opportunity then to link that with the code that we are going to demonstrate. So for Jakarta EE and MicroProfile also, for Payara Micro, for the runtimes in general, you have only one dependency, that's the Jakarta EE Web API dependency that you specify is provided. So as mentioned, don't put it in your WAR file itself, because the server has, the runtime has everything already. Keep it out that it is smaller, it will even avoid you that you have at some cases errors because you have duplicated classes on your class path. We have that application and that class that extends application, where we define part of that URL. Here I use that the context root. So that's not it's part of the URL. It's not really the context root. That's the URL part that it is associated with the application itself. So, but the link with JAXRS, and the URL is here now just a / so that means I did not specify anything. Yesterday I did API to show it where it appears, but now I just removed it, so there is just the /. And then we have those resources. There are some called it resources. There are various names, but most importantly, you have that @path annotation, where you link here that /product URL with this class, and then get on that URL is then this list of products, where you needed to write a bit of selection based on minimum maximum price, what was specified as query parameters, and also the product category there. So, and here then there is that check already, which is not really a business rule, because I said business rule should be within your logic of your application, not in your JAXRS methods like this one. But this is basically a validation of what of your input parameters, and that makes sense that you do it in the method itself. And here I check if the that the minimum price is not higher than the maximum price, that you specify it in the URL. If so, then you will return a 412. Sometimes it's not always clearly defined which HTTP status you should return for a for the certain error. It must be, I guess, it must be one of the 400 series, because the client, the user made an error, because he should know that minimum price should be lower than maximum price. But is that 412 or 406 or even another one? That's debatable. In this case, I try to do it as clean as possible, as according to the best practices, where I indicate besides that status, where I indicate a JSON message with the error. So I created a simple POJO that can hold that kind of message in JSON, what I mentioned, that you have a code and a text message which already indicates what the problem is, and then I can create that Java class, that instance, and I can define that as entity. It will automatically be converted to JSON also because I say produces here JSON. And then the user gets some in a correct, with the correct format, some meaningful error if he does something wrong. In the other cases, unless there is an exception, which I did not include here, but if there is some business exception, business rule validation, then you can use that system that I explained yesterday with that exception mapper, where you can throw somewhere in your code a subclass of runtime exception, first that business exception, for example, and then your exception itself, and that exception mapper will then return it in the correct format. But other than this, I assume that if I get some results, that it is okay, and that I can return a status 200 with the list of products again in JSON. And I'm injecting then the typical thing, a product service that implements my logic. I'm using some stream APIs to loop over the products here and just to filter them. And I'm also injecting my database here. Some call it repository, DAO, data access, etc. So that's up to you here, because my database is actually just in memory database with lists. Then I'm just injecting that as a unique CDIB in my application. There is one specific thing that is maybe a bit specific that I did not mention yesterday explicitly. For instance, if you look at all the commands here, one of the things was I can post to an URL, and I can specify the URL, the query parameter on the URL multiple times. That's something what is allowed in for URLs. That's one of the things I did not mention yesterday explicitly, but it is possible. And how can you handle that? Well, instead of just saying that you link a query parameter with one string, you can link a query parameter with a list. I think an array is also possible, and also a set. So in general, all the collection types, you can use them. And then JAVAPRO, the system itself, will group all the query parameter values for the product ID and will place it in this collection. And again, if I try to add something without specifying products, that's again a error, a precondition failed. That's about it. What I want to mention here, as I said, I used this database because then it was already a step up for the second version of the exercise here, that you have a second version where there was a question of changing this database object that it is using microstream. Again, you're free to do it whenever you like. You can even look at the solution, but more on microstream this afternoon. And for the rest, yeah, it's always same pattern. You define your HTTP method, your type at JSON here in this case. Here I don't have any parameters, but I define parameters, I define returns, and I do the logic what is needed. Here I have a special status 201, which is typical for those post requests, etc. But there is nothing specific, just using the same concepts that we have discussed yesterday. Any question about JAVAPRO CDI, mainly what we have seen yesterday that you still have? Otherwise, we can continue with the next topic, of course. Is category query parameter case sensitive? There was a product, you mean in the product here? Yeah. I assume yes, because I know that for sure that URLs here are case sensitive, so I assume that this this variable also is case sensitive. That's always a good thing to find out by just quickly testing it out. I'm not sure. Yeah, I did have a target, so it was maybe not needed, but Java min jar Payara Micro jar with my application. And then let's first do something what should work. So I get a list of all the bikes. And if I now change that category to something in a capital, then he does not recognize that. I mean, its value. Yeah, that's up to you. That is what you implement. That's in this case, I think I think I did not check about it. So if I just do something like this, yeah, then I have an error. Status not found. Because is that an enum? Because that would make sense, but I have to check. User item. No, it's product service. Product resource. It is a product category. You see, yeah. Here in this case, yes. Sorry. In the query parameter value is so the name is case sensitive, but also here because that's one of the automatic mapping rules. Where, yeah, as I mentioned, if you type it here on the command line, this is a string. So it converts the string. So it needs to convert the string to this enum. And by default, he uses the names of the enum, but they are in capital letters. So that means that if I specify it in lowercase, that here it says the status is not found. 404. Why is the URL not found? Because the mapping to a method which would accept something like a string is not there because it is a product category, but the value that you specified is not a product category. Is that a good thing to fail like this, or should you put here a string and do the conversion yourself and give some meaningful reply yourself? That's of course up to you and your team and the company to decide. Both are used in real world situations. I think even if you have something like a public static product category value of string, that you can do any kind of logic here yourself, so that you can do something like data to uppercase or to lowercase, whatever. Should do those things always with a locale, something that I learned through the years. As is not a good name, but anyway. And then you can search through that list here yourself. That's an option. I think also that works out of the box. And then you still can use here that product category, and you support lower and uppercase. And this method name is defined in the specification. So that is something that you cannot choose yourself. Someone else? Any kind of question around? Okay, and then let's start with microservices. And you probably know them, that the microservices discussion is already at least 5 years going on, and pros and contras, and the hype in the beginning, of course, and now people are getting more realistic and see also the downside of it. For sure, there are problems. There are some things that you need to consider before you blindly follow that strategy. So I'm going to do a little recap of that, let's say that 5-year discussion, and also put in some of my ideas, I guess. First of all, yeah, microservices have nothing to do with size. It is even a bad practice to just create microservices for the sake of creating microservices, and just every little piece of functionality that you can think about putting in a different microservice, because that will not work because of, for instance, the latency and the management of your entire system. If you have 500, let's say 500 classes, and you put 500 microservices out of that, that's of course not going to work. So it has nothing to do with size. A microservice can be 100 megabyte in size if you deploy it. It has to do with a business domain, orders, product, stock management, those kind of things. You can even have a more granular or a finer grouping. That's how you see fit and how you think that things need to be scaled. And for instance, if you know that only one part of your application, one area of your functionality maybe needs to be scaled more than with more than one microservice, then maybe just putting that one aside and all the rest keeping together as kind of a monolith, that also works. Microservices, they talk to each other through that REST that we have seen. So JAX-RS, and most of the time JSON. And yeah, the idea is that it should not be remote procedure call over HTTP. What in practice, it is almost always the case that you are not using that ETIOS. I find it so difficult name always to. But this is what I mean. That's the idea, that it is JSON, but that you also have some metadata. So you have the basic data what we have used now all the time, but you also have links, so that you can have some kind of auto discovery of the different URLs, the different endpoints that are available, what are linked. That was the idea of microservices, not what most people do, just JSON exchange data over JSON, over HTTP in JSON, which is more or less a remote procedure call. But if you then look at what MicroProfile REST client does, well, that is completely RPC. Things which are popular last few years, for example, is the gRPC framework, which is a binary remote procedure call. So people are really switching to that, again, to that RPC, and have an alternative for what was like 15 years ago used a lot in enterprise. What was RMI, remote method invocation, which is actually a variant of remote procedure call. But here you don't have those stubs, you don't have those things that needs to be transferred over the wire. It's pure your JSON. Your microservices should be independable, upgradable, and scalable. So that means you have 5 different, you have your order, your product, etc. And each microservice should be maintained by one team within your company, which means that if you have something like, let's say 15 or 20 developers, then not even developers, but team persons in your development team in general, that also means testers and those kind of things, then, well, you're not going to have then much microservices, because each team is normally 3 to 5 people. So then you don't have much space for microservices. And then you probably keep them together and build as one team a nicely structured solution, so that and some automation so that you can deploy quickly, so that you don't have those issues that with the monolith sometimes that it takes weeks or months to deploy something. Because that independable, upgradable requirement makes it, of course, quite difficult. Suppose that the product, the team for the product microservice has an improvement, but if that improvement also leaks to the API, meaning there are new endpoints, there the data which is sent is expected to be received and sent back, etc. That means that the other teams need to implement that new functionality before the new version of that product service can be used. Otherwise, the product service team replaces that microservice version 1 with version 2, and your entire application breaks down because the communication is no longer compatible. So that means that you either need or as much as possible, of course, always backwards compatibility, so that your other teams don't need to change anything and you can still, and that your application can still work, or that you need to maintain multiple versions. So that, okay, you have version 2, you put it in production together with version 1, and that you have a plan within the company saying, okay, other teams, you have 3 months, whatever, to switch to that new version, of the endpoints, and otherwise, our application will no longer work because in 3 months we drop that older version 1. So that independable, upgradable is a real issue with that microservices. That scalable means you have multiple instances, meaning you have probably something like a load balancer in front of it, or you need to have some functionality that the different instances can be found, etc. So that means you need also other kind of software. You also need to maintain that, you need to configure that, etc. So going from a single monolith to a full-blown microservices with all the bits and pieces, that is quite an investment. It's not something that you should decide after 1 week of thoughts, oh, let's go that way. And as mentioned, most of the time for very large teams and applications, there was even a comment a few weeks on the internet that one person said, well, monoliths are probably the preferred way for, let's say, 80% of the applications in the world, because all the rest have too small teams or the application is too small. It does not benefit. It does not take the maximum of the benefits out of it if you in all those other cases. This is the graphic that's Martin Fowler. Probably you know that guy. And from the point, the idea, that's of course a real issue with monoliths. If you need to scale a monolith, that means you have to duplicate the entire monolith, and probably only a single piece of functionality. You need more copies of that and not about everything. And then by that duplication, you have then also the synchronization, which you also have with microservices, but then you need to synchronize all the things like session replication, probably, and those kind of things. So it has pro and contras, and from a point of ID, microservices has some real benefits, but there are also major issues associated with it. There are probably 2 or 3 groups of architectures, how we can deploy microservices. On the left, you see one option where, in both options, actually, you have always that API gateway. That's also some additional software that you need. Because your client, it just sends a URL to one host or one context route. It does not know the different services behind the scene that you have. So you need a translation which says, oh, if I receive a certain URL, that it knows that there is a /product, for instance, in that URL. So it probably should need go to the product service. And where is that product service? And then he either looks it up with that service discovery, which is put there, or what is used also more often these days, that you don't have that service discovery, but that you have internally, you have your host name is your service. So you have a host name which is called product, and the DNS resolves that host name to, in most cases, then the load balancer, and that load balancer knows where your 2 instances are running, for instance, of that product service, and can forward that request to one of those 2. That's, for example, how you can make use of it also in Kubernetes with that service mechanism what you have, so that you forward that request to the service, and the service knows the 2 pods, for instance, which are running for that service, and use one of the 2 to handle the request. You also have that identity provider. Security is most of the time then already handled on that API gateway. Their tokens, because as I said yesterday, REST is stateless, so you need to specify all the info with each request over and over again, and then tokens are used, and I will cover that later on with security in MicroProfile, how those kind of tokens work if you're not familiar with it. But that kind of functionality is can be handled by the microservice itself, or it should also be handled by the microservice itself. I gave an example with the demo at that point, but it also is handled most of the time at the API gateway. So if there is already a request that comes in, that there is already some checks to see if it's a valid, that it contains, for instance, a valid token. And static content, that might be your JavaScript application, that might be other kind of application that then also serve that either directly or through that CDN, that content delivery network to your clients. A more or less similar thing, but then with more with Lambda functions. But in general, the idea is that you have different microservices that can be a pure Java application, as we have written, that can be a Lambda function, whatever, and it has its own, each microservice, each bounded context there. So for if you have 2 or 3 instances of your microservice, they can connect both, or those 3 can connect to the same database, of course, but each, your product service has an own database, your order service has an own database, etc. But most of the time, that means that you need to go always externally from your microservice to get the actual data. For instance, your order service needs to have the info about the product, so it needs to call the product service to have that data, which makes it rather slow, especially if you have let's say 5 to 10 calls before internal calls before you can assemble your response, which means that you have also a cache locally for each microservice of the data or at least the main data of your other service, so that it can also use that data immediately. And then how is that synchronized? That was then the main reason for that image there on the right, is that you have each microservice, if it makes a change, it stores it, of course, in this local database, but then there is an event which is sent out to an event bus or Kafka or whatever, which then propagates through your entire environment, and where each interested microservice then can pick up that event and update its local cache data, for example. Again, that's something additional on top of what you have with Monolith. So be prepared to move to those kind of environments, of infrastructures. Any questions around that microservice recap? As I said, I tried to do a recap of what is more or less the consensus, or how it's of the last 5 years, or what the typical cases are that people are using it. If no questions, then maybe I go to the next question, which then also comes up, is that people say, yeah, why try to use Java at all for cloud, like for AWS Lambdas? There are much better solutions for that than try to do it in Java. But that's not actually true. It all depends, of course, how you look at it. Because, for instance, with AWS Lambdas and all the other, or the similar other solutions that works on those functions, that the CPU that you get assigned for your process is related to the amount of memory. And if you then compare, yeah, your function need to start at the first time, it's what's called a cold start. That means Java needs to be started in your JVM, and we discussed it yesterday already. The startup times can be important, and people do the native compilation and that class data sharing, for instance, to get faster startup, so that you overcome that limitation of that system, that yeah, your process need to be started for a request that comes in. And then the vendors of those platforms, then they do something what's called, they keep then functions warm, as they say, so that the next request, if it's not, if the interval between the two is not too large, then it is already started, and of course, then it works faster. But if you say that you don't, if you don't assign a lot of memory, and with a lot, I'm just meaning 512 megabytes. So if you go to 128 megabyte or something, that also means that you have a very low CPU attached to it. So that's something like 1/4 of a virtual CPU if you take like 128 megabytes. Which means if you say I'm not assigning a lot of memory, that I don't have any kind of CPU power to process my request. So I can have a very low memory consumption, but at the cost of my response will be slow anyway, because I don't have any kind of power assigned to my process. So if you need sufficient CPU power, and I don't mean then that hello world, because if they say, oh, Java is not good and you should write it in Go or in JavaScript or whatever, then they always do that hello world kind of stuff, where you just send a name and you get an hello name back as a result. But real world applications, they need some processing. They need some power to get your response created. So if you assign that enough, so let's say one virtual CPU, then you have more than enough memory to run just Java. And for instance, with that technique of CDS, for instance, some of you might know him, Adam Bean, has tested a few scenarios around it, and then if you assign like one virtual CPU to it, your processing with Java on an AWS Lambda is comparable to that from Go to that from JavaScript. So in real world scenarios, Java is more than enough, is more suited, is especially more suited if you know already Java, than that you need to learn, for instance, a new language, because, oh, I'm going to use AWS Lambdas for my microservices. I'm going to use those functions. So you need to compare real world scenarios. Don't get tricked in those hello world type of articles saying that Java is not good. I'm not sure if there is any question around this topic. There is a question from Nils. So if you have one Lambda function, will that be one microservice? Yes, you can define an entire microservice, or actually an entire Java application that might be even a monolith. Of course, that's not the idea, but you have just one process, one microservice that becomes your Lambda function. So now that we have discussed microservices, where you can run them, you can use, so you can use Payara Micro. I'm probably someone did it already. I have no actual evidence, so I was not involved with one of the projects where they used Payara Micro to run on AWS Lambdas, but I guess there are people that doing that, so that's not an issue. So we know where we can run it, and you just need to make a decision how, from an architectural point of view, as I mentioned in the beginning also, of how I'm going to deploy it as a fetcher, and how I'm going to deploy it as a Lambda or as a normal service within Docker and Kubernetes, for instance, etc. So make that architectural decision, and that's more or less independent of how you implement with Jakarta EE, for example, and MicroProfile, your functionality, your business logic. MicroProfile, we mentioned yesterday config already, to define values within your environment so that you have one single WAR file, one single deployment that can be used in test and production on alter than that you are sure that if you properly test it, that you can be safely say, well, I have confidence that I moved that same artifact to production, and I know how it will behave because I have tested that exact piece of bits and bytes. But if you remember that client, that JAXRS client that we showed yesterday, I mentioned it is quite low level, and you need to specify I'm going to call that URL. It will have that body, those headers. It will have that HTTP method. So that's really a low-level procedural way. And MicroProfile REST client, the approach of that is that you have more a type-safe approach for invoking those endpoints, RESTful services, and that can be your own microservice that is running in your environment, or that can something externally. It does not matter. Actually, you just call another endpoint, and you would do that type-safe and in what's called a declarative way. And even it looks like a regular JVM method, and that has some nice advantages, especially if you're if you're splitting up your monolith into different microservices, then that MicroProfile REST client can become really handy. Let me show you the code. It is here. So if you want, it's a adapted version of the one that you find here. So again, start microprofile.io. If you select Payara Micro, and that's random, so it is every time at another place. If you select here that REST client, then you get a zip file with two projects in it, a service A and a service B. And service A calls service B. We explicitly did not want to use that client and server because it can be used in any kind of configuration. And that service A and B, I have extended that to show a few things. So both of them are, and I'm going to switch back to my main branch because I've showed the solution, because I see again that I still have some probably, or it is not in the main branch, or it is also there. I can update to the latest. Always like to use the latest version. So service B, you're using MicroProfile. You can use it any kind of thing, but it is again, it exposes a URL with the path parameter, in this case get, it takes in that, it does a processing and returns it. That can be anything. It is just the idea of I have there at some part sitting something which returns something based on inputs. That's the idea. Probably I can run this already, and then we can see how we can call this endpoint in a more efficient way. And since we are now going to run Payara Micro twice, you need to specify, of course, the port on which it is running. So here I'm going to call it, that's mainly important for the other example. I'm going to call this service B, this window, so that you can see it. It's not in the correct location, indeed. So I start my service B there, and this will be my service A. And service A will call that, and I can do that with the Jakarta REST client. No problem. I can build that client, I can say the targets, etc., etc. But let me show the idea. That is that you inject a service that represents that remote service, that URL. And when I do something, I actually say, well, this needs to be translated to that path / parameter. And it is a REST client that is injected here. So this looks like a normal Java method, of course, but the service here is an interface. MicroProfile REST client implementation will create a proxy around this, which in the case that you call this method, that this parameter is converted to a path parameter like you have specified in this path, and the rest of the URL is configuration, because probably that is, or that should be, different between test and production. And now I can immediately say why this can be handy if you split up your monolith, because probably that, especially if that microservice was part of that monolith, then you have a service, a regular CDI bean, which you can inject here and that you call in this way. Now, by just putting here REST client, you don't need to change any kind of logic that you have specified here. And the only thing that you need to do is define this service, which defines the contract of your remote endpoint. It returns, in this case, a string, etc. It can do automatic conversion also from Java objects to JSON. So it does that conversion also automatically. So if you, like we had that person in one of our examples earlier. So if you pass a person or you retrieve a product here, whatever, then that JSON is automatically converted to the Java object, an instance of Java object, where in the case of your pure usage of that REST client in JAX-RS, you have to do those things more or less manually, in the sense that you need to call then a JSON processor yourself. There are a few things special, of course, here. You have an interface and you need to define that it will be scanned during startup, and this is kind of a marker, and that it knows that a proxy needs to be created for this interface. And to be 100% sure, because that's not always the case, that interfaces are picked up by the CDI implementation, it is best that you define a scope for it, but yeah, application scope is here the most useful thing. I will come to that later on. That's part, the second half of the first example. And here, the method itself that actually looks identical, and you can, or you might even copy that. You might even copy that from this definition that's identical, but now as a method within that interface. Let's start it up first, and then you will see, and then I can say the other bits and pieces that are missing. I don't specify a port here, so it will be port 8080. And I'm going to use another window for my curl commands. Which is here. This call went to service A went to service B, that got a response, and I send back that response here. The details follows. This test parameter, so this is capturing this kind of construct, so that's why it is here. This service here, we now already know a large part of the URL, but not the actual host, for instance. And that's done through a MicroProfile config value, where you define here the name of that, the fully qualified name of that service. So that's this one. So in IntelliJ, you can copy that name, the full name, so that you have the package and the name, and you can paste here. You have in the other IDs, you have something similar also. Yep, that's what I'm now explaining. The question from Christian was, how does service A know where B is? By this configuration here of MicroProfile config, you define that that service, the URL for MicroProfile REST, is this part already. So HTTP, there is something hidden behind it. So that's here the complete URL. So partially it assembles it from this configuration, and it adds things like here this /parameter based on this parameter that you specify, and then it calls service B. Service B doesn't even know where it comes from. It can be on the command line, whatever. I guess you get that. It just returns it, and my proxy converts here the result back and returns it as the response of that first call. I find it very handy that you can call things like this, because it makes also it makes it much clearer. Or you could hide, of course, a JAX REST client behind a method like this, where you actually build up all these bits and pieces of that standard JAX REST client and then do the call. But here, a lot of things are taken care for you. Also, as I mentioned, the conversion to and from JSON. But one thing can be confusing, especially in the beginning, and especially that you need to know how what the actual value, what the actual URL is, what he has composed and that he will calling. Because if you make some mistakes here in this URL, or you made a mistake here, etc., the only thing what you see is a 404. It says, and in the case that service A tries to call a URL and that does not exist, so you get a 404 back. Or even in the worst case, if you have completely have the configuration wrong, where you have your application wrong, then there is even nothing listening on the thing that you're calling, and then you get a connection refused or something. So it can be, especially during development, it can be a bit tricky to know what you need to put here, for instance, and what needs to go here in that service. And for that reason, you can have something like a request filter. Remember what we have done yesterday with that request filter? It was at that point a container request filter. So for each request which comes in on the container, on the server, now I'm creating a client request filter. So every time a request goes out, is done by a client. And what I'm doing is I'm printing out that URL. Well, it's called the URI. So that URI which is called or will be called, I'm just printing it out, which makes it easy to debug, because I have then my complete URL here. And I could use that to check if it works or not, because that directly calls service B. Wouldn't this be a good example of code generation, is the question for the client for service A that calls OpenAPI. Yes, it would be good, but I'm not 100% sure there is a generation available that makes use of this MicroProfile REST client. I know there is one for JAX REST clients. I'm not sure there is one for MicroProfile REST client. So that's something that I should check. But I come to that OpenAPI and the generation of clients in a moment. And yeah, of course, you should not have this in production. So this is not a CDI bean, but you can then from that config provider, I remember we can have config provider, get config, get value. We can get a Boolean is production, for instance, and we can have something, if not is production, then we print it out, for example. That's, of course, the proper way how to do it, not hard-coded here. But then you, with a configuration value, you can switch out, you can suppress this kind of functionality. So I suggest that you play around with those things. As I said, with that starter here, you get something which is working, and then you can start playing around it, modifying it to see how it works, how it behaves, and then try to do it in your own solution. And again, this service B does not need to be under your control as long as you know the definition of the endpoint, what you should type, and then you should define that same contract here. And it has even another nice functionality. Remember, we talked about asynchronous yesterday, but that was on the server side. Now, with that MicroProfile REST client, you can automatically have asynchronous also on the client side with minimal effort. Again, you can do that all by your hand yourself. That's fine. But yeah, asynchronous and callbacks, etc. For those that have experimented with it, it can be tricky sometimes. So this is again some endpoints in the world which is heavy in the sense that it just waits 2 seconds, but it prints out some info messages so that we can see the flow between the different between service A and service B, and how that and that we actually can, so that I can prove that it works asynchronous. So here is nothing specific. That can also be asynchronous, whatever, we don't care. But now our definition, and that is similar to what we have seen on the server side, we also say that the return that we get from our remote service is not just string or a certain project class like a person, whatever, but we return again a completion stage, which is then the trigger for that implementation of MicroProfile REST client to start working asynchronously. If we just in the same way inject that as a REST client, this is required. This is a qualifier, and so that CDI knows that this is something specific, just as with the other one. But we have a heavy service with our contract, so we can call a method. But this method now returns immediately without waiting for the result from the remote service, because it is asynchronous. So we get something back that implements completion states, probably a completable future, but it is something that follows this interface for asynchronous work. So we can make our call to that remote service at the beginning of the method, for instance, like I do here. We can maybe call another service, but in the meantime, our microservice, our method, can do something else. So it does not need to wait it, because at some point we need that value, but we can do already some other work without having the value from that other service. And then we are at the point that we say, okay, now we have to wait until the result is there, or if we have already have the result. So then from that completion state, you need explicitly to convert it to a completable future and then do a get. So this will wait until we have the result from the remote service. But again, we don't need to implement anything for that. We don't need to do that polling to check that if it's there or not. Just get me the value, and probably this is not a good way. You should say a timeout, because otherwise, if you have some malicious other service that just accepts requests but never return responses, then yeah, your process can block here also. And once we have that result, then yeah, okay, we have received that result, and actually we just return it here for that asynchronous. Main point is here that we have all those logger messages, so we can check that in the logs. So let's call again service A, which does some processing on its own, call service B in an asynchronous way, and let's see what happens. After our 2 seconds, we have the result. That's already nice. How is that? How did the flow go between the two? So we start here, and we start by calling service B at 10 seconds and 302, not milliseconds, but 10.302. But immediately, well, almost immediately after it, we continue in the caller. So certainly we don't wait 2 seconds. And here we received that request. So it was 10.721. So that's even a bit later. We received it here. 2 seconds later, as expected, we return the result from the heavy service. That was 12.740. And from the point on 11.56, 569 here, we are waiting for the result. And almost immediately after that, this one has sent the response back, then we received here, and we can handle the result from that service B. So this is a very handy way, which is not available in JAX-RS client itself. You need MicroProfile. A REST client for that is that asynchronous way of working. Again, that can become more complex because you can then apply, you can, based on the result of the first one, you can call then other things, etc. So you use that result for another asynchronous call, etc. So this is not super real world, but it already shows you that you can call on the client side services, URLs in an asynchronous way, in a quite easy way. Any questions around this asynchronous and MicroProfile REST client in general? So we can define it, we can call the other service, and we can make asynchronous calls, but that was the server side, but we talked yesterday. Today we are talking about client side. Next is the Open API. probably you know the name Swagger. And so first it was a framework which actually came up with a way of documenting your endpoints. Let's open the browser, and if I go to that local host, what was it? Is it service? No, I don't need to specify the service, of course, because it is runtime level. I can specify here OpenAPI. So Swagger came up with a way of describing your endpoints as a kind of documentation, for one thing. And based on this, you can generate clients. So you can, for instance, create a Java client that can call these endpoints because it can see that you need a get, that you need a parameter, for instance, and what the response is. Here, of course, it is just a string, but yeah, in more complex things, it makes, of course, more sense. It can be also very long, of course. And there are then even tools built around this. So if you fetch this in those tools, like JavaScript tools or that, and then you have a nice list of all the endpoints with, and you can even say what happens if I submit a certain value, then so you can do live testing of your endpoint if it is, of course, available, but it should be available. Then you can do that live testing. So that was one thing what was invented, let's say invented by that Swagger team. Later on, they said, well, we want to open it up to the world, so we make a specification audit, and that became OpenAPI. That's one of those specifications with that Cloud Native Foundation group. And you see, without doing anything, we have some info. It is some basic info. It is something. It's but it's not. It does not have the entire detailed description. Of course, that is something that we should add ourselves as developer, if we want, of course, to have something like an OpenAPI schema for our endpoints. It is by default available on this URL because OpenAPI is one of those core specifications of MicroProfile. That means that your server needs to support it by default. That means you have it there available. I think also here, I know for Payara server, but I think also for Payara Micro, you can hide it behind some secure endpoint, in the sense that you need to provide username and passwords so that not everyone can peek into your endpoints at production. Because you give really a lot of info about your endpoints if you expose this, of course. Then you open up, you make it quite easy for hackers to know what endpoints there are. But as I said, it is a bit basic, so you can define additional annotations for, I think it's called, here you have, I thought there was something like description. It's not description. Let's use one of the other and see what the name is by looking at the other ones. So you have the OpenAPI definition, you have operation, etc. So you have other annotations that you can put here. For instance, you can define that this is an operation. And one of the things that you can do is write a summary is write a description, etc., and those kind of things. If you do that, then that information is transferred to that Open API schema, and there are added additional items in this. Is it a YAML file? Yes, it is based on the YAML structure. So there are other entries here containing your information that you write here in that info. You have also for, it's not API response here, but you can also write some description around your parameters, etc. So you can add additional info to your Open API. And then the question came also up, can I generate clients on that? Yes, you can generate clients. So Open API client generator for Java then. I think this one, this is just a documentation. Try it out. So yeah, that's how you do it locally, but I should have looked it up before. That's coding gen, but is it, for instance, this live demo? Hopefully this is what I mean. If you put a or link to the certain Open API document, then you get it like this, and then you can try it out. But I thought you could also do it online as a tryout, that you generate some Java classes that are capable of calling this. I write it down so that I can look up the actual link for later on, so that I can give you the link in the chat later on. Which saves you then a few things. Was maybe too quickly to click on it, but you have also, for instance, a Maven plugin that based on a certain API that it generates Java classes on the fly during your Maven build, those auto-generated classes, etc. So all those things are available with that Open API these days. And it's then up to you if you want to use those auto-generated, or that you prefer to handcraft your things, your clients yourself. That's because a downside of that auto-generate can be if your Open API changes suddenly, then yeah, okay, your code might not call then or not work anymore. But sometimes small differences can result in different Java methods, so that your application does not compile anymore, but actually the URL or the old version still could call that same that new updated URL. So it is thing that you need to balance out of that if you really want to depend on this Open API stuff or not. Does that satisfy the questions around Open API? Or are there more questions? What I maybe can do is open MicroProfile, Open API spec, then there are there you can then see that operation that I mentioned, but you also have, you can clearly define when you get a certain response code with that API response. You can define what else? You can define those servers if it's not the local host, of course, because now it's taking local host by default. Can, and if you're behind the proxy, that can be important to explicitly define the external hostname, not your internal hostname. There is even a possibility to programmatically, with that filter here, to programmatically adapt that thing so that you don't, that you not only need to rely on annotations, but that you can also rely on some Java statements to augment that OpenAPI documentation. So I don't see any questions for the moment, so we can continue then, I guess, to the next one. Or it's already 1 hour and a half, so maybe we take first our 10 minutes break so that I can get me a new hot drink because it's cold. And then we continue with the next microprofile specification. So yeah, we have covered then OpenAPI, which is mentioned mainly documentation. You can also use it for client generation. I've put here in the slides, I see now that there is support for microprofile REST client. So during our long break for dinner, I'll see if I can find some references for that. The next specification in microprofile is fault tolerance, which is, of course, very important because in that microservice environment, it is basically a distributed system, which all the problems of a distributed system. There, it's already a quite old, I think that you need to call it a document or description of what all the things that can go wrong in those distributed systems. It's called the 7 fallacies of distributed computing. And yeah, it's about the network that will fail, services that are no longer accessible, things like that you don't have a penalty for calling external systems. You still have you have those latencies, so it's not instantly and those things. So you need to take that into consideration. And because it can fail, means that you need to prepare that when you call an external service, that you will get an error that it will fail. And then microprofile fault tolerance is then about a set of annotations that make that call more robust, in the sense that you have default behavior that you can apply there so that it will behave better. But yeah, if your network is down or your connections are down, then you probably only can return that there is a problem to your client, but at least you don't have those exceptions that propagate from one service to another, and that the client gets a internal server 500 on the screen or something like that. I'm not going to show all of them. I'm briefly going to touch them, what is available, also by showing them in the code. I don't have any exact prepared code because they are rather straightforward. The first one that's I'm going to describe is that timeout, which you can use on both sides. So you can, for instance, here define on this level. So on the server side level, that you have a timeout. timeout of a certain time. By default, it is 1000 milliseconds, but you can specify the value yourself, and you can even change the unit to so that it makes more sense maybe to define it in a different unit than in milliseconds. What happens then? That's kind of interceptor that we have seen before. So that means that after that timeout and your method did not return yet because it calls another service, or it calls a database which fails to respond in a proper way, and it's way too slow, etc., then you immediately return already to the client that there was an issue by default, or you can do some alternatives as a fallback and those kind of things and default values. But then it is an exception is an exception, and its certain HTTP status is immediately returned to the client if you use it like this one, just pure the timeout. That makes sure that you have already some feedback on your client that's within your application, your JavaScript application, or whatever, that you have some information for the user that it failed, or please retry later, or whatever. You can also put it here on the interface, and then it is the client specifically that the call to this client's methods, which is then remotely, as we have seen, can only take a certain amount of time, and then it is also an exception is thrown, which, for instance, you can capture them in the method where you call it. For instance, you can do here a try catch and do something else, or find here something else instead of the default, which is, I need to keep the default, of course, that you have something like a fallback. Fallback, I can probably show it more easily here. If you define a fallback, then you have two options. You can either, it is a class or it is a method. Indeed, I was looking for that and I did not see it in the autocomplete. You can have a method, which is not the preferred way, if you ask me. Because then you can have, for instance, and you need to have the same return type here, of course. You can have a alternative and with that string parameter. And I can say that after my timeouts, this alternative, this fallback needs to be called. Which looks nice, so that you can return data. Make sure then that this is more certain and that it does not fail as easily as your original, of course. The downside is that you have here a method name in a string. So if you replace this, you don't get any indication during compile time, during deployment, that these two names no longer match. So that can be an issue. So the method is an option, but I prefer here a class. Can also define here an alternative class name, for instance, which does not exist, of course, because I did not create it. But that fallback is then an implementation. That class is an implementation of this interface, the fallback handler, where you have a method, which and within execution context, you get information about the parameters which are specified. But that makes it, of course, much more safe and secure, type safe. Because if you do a refactor, a rename, then your IDE will automatically rename this also, of course, because it is not a string anymore, it is an actual class name. So, yeah, timeout and fallback are used in combination most of the time. But there are other ones, and you can combine fallback with other annotations. For instance, I forget that I cannot click on it and select it, but you have here the retry, for instance, where it might be the case that most of the time an external system that you know that external system is, well, it's called a bit flaky. It works 99% of the cases, but sometimes one of those requests, yeah, that completely goes sideways and you get errors back, etc. But if you call that endpoint again, even a fraction of a second later, then it works fine. So then it makes sense to say, let's retry it. By default, you can say only retry it 2 times or 3 times. You can also specify a delay. So if I get the error back, do I wait like a few 100 milliseconds, or do I try immediately again? After that I have tried twice to get a response and that still failed, then yeah, either you can go to the fallback, or if you don't have that, then your exception is propagated as an HTTP status to your client, of course. But that retry can be sometimes useful to cover some momentarily glitches of your system in a nice way. If there are any questions of one of them, please shout out or type in the chat so that I can cover it, because otherwise I continue with the others. The bulkhead and the circuit breaker are from a different type. So you have timeout, retry, and fallback. It's a group of 3 which are used many times in combination. As I said, timeout, fallback, and retry and fallback are used many times in combination. Fallback can also be used with circuit breaker. And what is circuit breaker? That's actually the same circuit breaker that you have in your house, your electrical circuit breakers. If you want to find out all the details about it, then have a look at one of the examples, because circuit breaker is a very sophisticated one, but it can be, yeah, sometimes you need to do a bit of math calculations to see what is happening. Idea of circuit breaker is that if you the execution of this method, or the execution, if you call it on the client, fails with a certain ratio. By default, as you see in the pop-up, double failure ratio, the default is 0.5. So if and then you have the request volume threshold there. So if out of the 20 last calls of that method, if there are 10 or more that failed, then your circuit breaker goes off. Switched off, just like in your house. That means that for a certain the duration, and then you have that delay there. The third one, long delay is default is 5,000, and the delay unit is again milliseconds. So for 5 seconds, every request which comes in those 5 seconds will always be rejected. It will not even try anymore to execute your method. It just returns immediately with a certain exception. After that 5 seconds, then you go to the what's called the half open state. And that's the last one there in success threshold. So after that half, it is again open. So there comes a request in, and that is tried. Is that one request fails that again, then you go again in a delay of 5 seconds where everything is rejected. Was that successful? Okay, then either you go to the open state in that case, because you have one successful, that means you have normal operation again, and he calculates the statistics of the next 20 then, and to see if it needs to be switched off again or not. But if you say success threshold is 5, for instance, then 5 calls to that method need to succeed in that half open state before it goes to the normal operation with that statistics for the 20 values, or it goes again in a delay of 5 seconds. That's the detailed working of it. As I said, there is some calculations going on. So what I did when this came out, I started playing with it, and I tried to do the math myself and see if how it exactly behaved and to understand it better. But what is the idea behind it, the purpose behind it, is that the circuit breaker tries to avoid that things that are not stable, in the sense that it fails most of the time, that at a certain point it is switched off so that it kind of protects your system. Because most of the time, especially because you also have that retry there, if another microservice see, oh, it failed, and it tries again and again, and which might even compromise your system more, so that it becomes even more unstable, because there is a memory issue, there is too much garbage collection going on, etc., or all those kind of things. So it brings a cool down system. It cools your system. The idea is that it allows your system to cool down, and that it can resume normal operations again. That's the idea of this circuit breaker. Because we all have probably the bad habit, if a web service website does not work, we click F5 or refresh and over to see will it work now. So if there is something which is not working as expected, systems and people have the habit of even issuing more issues, so that can be more damaging to your system. And that's the reason then that you have that circuit breaker to just switch it off for, in this case, 5 seconds by default, and to see if it's stable again afterwards. The last one is the bulkhead. And bulkhead is to protect your service also, but protect for an overload, protect for denial of service attacks. In the sense that with bulkhead, you have here the default value is 10. So if you define bulkhead just as it is, then only 10 requests can be executed simultaneously by this method. If number 11 comes in, while the other 10 are still within that method, so it's again an interceptor, and it counts how many requests are actually within the method. If the 11th comes in, then it comes in a waiting queue, until one goes out, and then that one is allowed. That's the classic protection to see that you know by design or because this calls a database and you only have, for example, only a connection pool of 10 and you cannot go higher, then yeah, it is you can already protect it here instead of trying to let it pass and then it might fail, and or as I said, a classic denial of service when you have thousands of simultaneous, you can even block that here. Of course, there are other techniques at other levels where you have those kind of firewalls and new technologies even that analyzes your traffic and find out if there is a attack going on, yes or no, and block it already at that level. But here on this level, there are also several reasons or possibilities to limit the amount of requests as simultaneous requests to a certain method. So that's basic stuff around fault tolerance. And yeah, depending on your use case, they can be quite useful to implement this kind of functionality without the need to implement interceptors yourself, or even use third-party libraries which provide this, so that that becomes easier. There is a question from Nils saying the throttled requests are not lost, they are just put in a queue and executed later. Yes and no. I'm going back to Bulkhead. You have an initial, the value is 10, but the waiting task queue is also 10. So if there are 21 requests coming in, then that number 21 is rejected. Is immediately rejected, and a response is sent back to the client saying, not sure which HTTP status that's defined in the spec. You can look it up so that your client knows that your endpoint is not accessible at this point. So if you say, okay, I'm fine by putting the people in the waiting queue, and then again, this can be combined with timeout. So because this timeout starts running at the moment it arrives. So if it takes too long before you can get your your slot here, then you can also use timeout, etc., etc. So all those things are combinable to one larger solution. I touched already things like, yeah, what if your system is not healthy with that circuit breaker? It might be that it was overloaded momentarily, too many requests, there is a lot of garbage collection going on. But can we actually see that externally? Yes, that's the idea of the microprofile health and metrics. In general, that's what's called observability, because you have probably more than one microservice. And it's not the idea that you, there's another question to use at Bulkhead, have to use synchronous. No, Bulkhead also works on asynchronous. It works on both. So I thought, because I see now in my head, there was the idea that you could define that Bulkhead needs to use a specific thread pool or not. I did not see that in the parameters, but but it also works with asynchronous. That's for sure. Because that's an implementation detail you don't need to know, well, yeah, you see it, of course, on the method, but yeah, how that is handled internally, that is something that you do not need to know. So it works on synchronous and asynchronous. Yeah, I was saying that you have probably several services running, and yeah, you are not going to go manually one by one to see if everything checks out. You want to have automation, you want to have a system which is dedicated to following up, to see if those services are still running, and probably are all like Kubernetes that needs to know if there is an issue with one of them. For instance, there is one service not responding anymore for whatever reason, then I can just kill that pod and start another one in the hope that that one works better if I start up a new one. That's the classic thing of a computer. When you have an issue, the first thing that support asks, did you restart your computer again? And does it work then, or do you have still the same problem? Here the same with Kubernetes, it says, well, there is a problem with one pod. Let's kill it and start again the same process from a fresh start, and hopefully it solves the problem. Sometimes it is, but if your database is not accessible, then of course that will not solve the problem, but that's another discussion. So systems like Kubernetes, but probably also you want to have a dashboard, or you want to have receive a message, a text message if there is a real issue with one of your services. So you need to have some kind of automated system that can interpret your status of your environment. And there, health and metrics comes as the MicroProfile health and metrics helps there. And it is building on top of standard things, as I said. Kubernetes uses also what's called the health endpoints. And for instance, you can point your Kubernetes configuration to the health endpoint, which is exposed by MicroProfile. So then you can integrate those things. I guess my application is still running. So instead of Open API, I can do metrics. And again, by default, you have a rather long list with default information about your system, metric values about system. Some things are really static and does not change at all, like the number of processors that the number of cores that I have available on my machine, that does not change. But of course, things like the average CPU load, that's 2.3, it's doing almost nothing. You can also see how long your Java machine is running. You can see if the number of threads, for instance, if that goes dramatically up, then because you have asynchronous processing and maybe there is something blocking, you have, for instance, like blocked threads that, or the deadlock, that two threads blocking each other and messing up the system, then this value goes up, for example, etc. So you have all kind of there are some things like garbage collection information. So there are basic values of your JVM by default, but you can also define your own metrics, and that can be really system related. For instance, that can be the number of open connections in your connection pool to the database, so that you can monitor that. That's something that you have to implement then, but that's something possible. So that's quite technical value that you can also expose, but you can also create your own metric, which is more business-wise. For instance, the number of orders that are placed today by the system or handled by the system, so that you can have that information also available through that system, because for those who are thinking this is a rather strange way of putting data, this is the Prometheus standard format, which is a time series database. So that means that this is normally captured by those Prometheus scrapers, or I think they are called scrapers, that take this data and put it in the database. And it is a time series database. It does it every minute or so. That's how you configure it. And then you can follow it up during the day, or you can even, as I said, follow and create some statistic. How many orders did I get each day? And you can create a nice graph for management based out of it. These are the default ones, and yeah, I think I have to, do I have them here? No, I don't have them here. So then I'm going, because I also need it for the security, I'm going to create an example with, going to restart anyway, because that's more than half an hour. I'm going to generate a project with all the examples, and then you will see an example of metrics and health, etc. There. Open that. And then I can open that generated projects, downloads, demo. So that's, yeah, service A and B, okay. Well, you can do the IntelliJ trick and then he finds it, yeah. As a metric, for example, I can just create a counter. As I said, the number of orders, I can give that metric a name, and I can just do an increment at some point. I also do a return here so that you see that both values are in sync, but yeah, that's of course not really useful in real world. But by incrementing that counter here each time, which is then exposed through that Prometheus, then I can have that, I can have my custom data there in that database. But there are more things that also can be useful. For instance, you can expose timing statistics. So with this at timed annotation, then it keeps track of all the timings for each execution, and then you can calculate statistics. My average timing at this point, at this, or 50%, my median value of the request was 238 milliseconds, for instance. So then that's also a thing that you can then follow up to see what is my average response time for that one method, or of course, if you do it at only at the first level, then you see more or less the timings for the user. So you can use those metrics in several ways here. The point is, these metrics, where was it? And those zoom windows are always where I don't want them. Point is that there is no interpretation of these values. You, as I said, you can put them in a database. You can have some graphs, but of course, this value is very low, so that means it is a good value. But if you have a average CPU during the last few minutes, for example, which is constantly higher than 70%, is that normal or not? And that depends on your application, of course, because if you know that you have an application which is hardly used, but you see that the CPU is constantly above 70%, then you know that there is something wrong. But on the other hand, if you know that you are that service is a highly used service with many simultaneous requests, then probably 70% is fine. So there is no interpretation about these raw values. So metrics is about raw values. And based on those metrics, you can then define if your microservice is healthy or not. But as I said, that is an interpretation, and that means that by default, there are no checks available with MicroProfile health. Because it all depends on the environment. The only thing what Payara Micro does is that when Payara Micro is running with an application successfully deployed, the status is up. If it is running without an application, the status is down. That's the only thing that Payara Micro can do for you. And that's not even defined in the spec. In the spec is just, you have to define your health checks yourself. But the extension of Payara Micro is that you have by default one check if there is an application running, yes or no. So how do you write those health checks yourself? And a health check can be, for instance, is my database accessible? You need to do a few things. It's not that difficult, but there are a few requirements. First of all, you need to implement a certain interface, which requires that you implement one method. And you need to define the type of health, because these health endpoints and these health checks are really designed towards Kubernetes, and Kubernetes has what's called a liveness check. They have a readiness one, etc. So all those different checks, you can point them to different endpoints, and so you need to define, is this now a health check that appears, for instance, only for liveness or appears only for readiness? So there are qualifiers. You have those three things, readiness, liveness. I thought there was a fourth one, no? A third one? I think there was startup now. And probably this is just an older version where there is not that one available, but anyway, you have to define where it appears. And then it's up to you to define the logic of your health check. Then again, you can access those metrics. You can, it's not like this, but I think it's like this. You can access the metric registry. No, you have to inject it. So you can inject the metric registry, which contains all the metric values, and then you can interpret, for instance, your CPU value yourself, saying, if I'm over 70%, then something is wrong, so I'm putting my health check as down. You can put that here with up or down here with that method here. I say if it's up, you can also, by default, these are all up, but that's just a demo. And then you can use that, or you can implement your own thing. What I once did was that I implemented a check to see if the database was still accessible. So every time again, you need to be careful with that. Every time that this endpoint was called, there was a check to see if the database was accessible, yes or no, through the connection pool what was in action, in use for your application. So these are those health checks that you need to then implement, because the logic is depending on your use case. Health and metrics now are MicroProfile is also switching to actually the micrometer way, which is another framework. So they are now making the switch, and I'm not sure if it's available in MicroProfile 6, which is out next week, but it might be. But the IDs stay the same. You have, it's just that this is a slightly different way of working. Any other question around health and metrics? If not, then I can briefly go over security. Sadly enough, security is always a bit behind. And with REST endpoints, most of the time you work with JWT tokens, JWT tokens. For those who does not know what JWT tokens are, a super short intro. Those tokens consist of 3 parts. You have a header, you have a body, and you have a signature, body or payload. And the header and the, well, everything is base64 encoded, and the header and the payload are just JSON constructs. Header says, that it is of type JWT, because there are different types, not going to detail that. It says also which kind of signature, how the signature is calculated, etc. And the body, the payload, is then the actual content of your token. Like this, you have a name, you have a subject, which is the unique ID for your username. And you have, for instance, here that the token is generated at a certain time. Issued at is this is the short of issued at, which is a timestamp, a Unix timestamp. And that signature is then based on public and private keys, is then a hashing and a signature mechanism described here. There are several, which takes the header and the payload, and it calculates a signature, and later on your client can, with the public key, can then verify if that header and that payload is altered, yes or no, by checking if that signature still match with what is specified. That makes it so handy to use JWT tokens, because they are self-contained. If a client, like your JAX-RS endpoint, receive a JWT token, it only needs to have the public key, which was used the complement of the private key. You have also symmetric one, but I like to explain it with public and private ones, because that's more secure also. So that only needs to have that public key, and it can check if this data here is valid. And in this payload, what people put there then is like your username, your roles and groups. Is he an admin? Is he what are his different access rights? And it is secure in the sense that if someone tries to tamper with that payload, because you can just decode this base64, then you have this, you alter it, you again encode it, well, that will be detected because your signature no longer matches. So although username and the roles and permissions that the user has are sensitive data, it is very secure, and you cannot hack those kind of, well, everything can be hacked, but it is a rather secure systems. And MicroProfile JOT authentication specification has some support, has some automated functionality available, automatic functionality available to handle these kind of tokens on a header, so that you don't need to take care of decoding it to see what's in it, etc., etc. These kind of tokens, they are generated by your security system. So if you log on, that's most of the time an OAuth 2 system. If you get redirected to that server, there you provide your credentials, even with two-factor authentication, with text messages, with etc. They issue these kind of tokens, and your client can just forward that to the server, and then the server knows who made that request, what was the physical user behind that request. And then I said very briefly what you need to do is then at the application, you specify that you want to make use of that JWT system from MicroProfile as authentication method, and that you declare, for instance, that's something that Payara Micro then knows which roles you expect in the and which roles are important for your application, so which roles you expect in the token. And then you can say that a user that has the role protected in the token is allowed to execute this method. Someone else that does not have that role will not be allowed to this method. It will immediately return a status 401 unauthorized back to the client. You can also put some custom values in the token. You can put basically anything in that, and you can extract that value by injecting the claim custom value. If you want to mix secure and unsecure parts, is it there? No, it's not there. You have an annotation which escapes me now. Instead of roles allowed, you have another one. Hopefully it is in the same directory, permit all. So of course that does not make sense, but permit all means that the token is not verified, and yeah, of course no roles are checked. So these are publicly available methods within your application, and other endpoints can be protected by these kind of roles. Again, as I said, very brief how you can do security, which is very common these days, those JOT tokens, and OAuth 2 for generating those tokens, and OAuth 2 server. There are servers either on-premise, like Keycloak is one from Red Hat, but you have also on the cloud, Auth0, even Google. If you connect to your Google Mail, for instance, then you actually are using those kind of things, and you can use that as a basis to base your own security. for instance, I used to work in a company where all the internals were also were based on the Google authentication system. So if we created internal programs, we could just use those JOT tokens, and we could see if someone from our company logged in or it was someone external. For all those things, it's quite short overview, but I hope you have an idea of what that Open API, health, metrics, and security, what the fault tolerance, what the idea behind all those specs is. And if you need them, probably you need them, but if you need them, then you can look up some examples you can generate based on that starter. I closed my starter, I guess, that you know, it's still here. Based on the starter, you can get an example. You have also open tracing to do to follow some or do debugging at a certain level, and that you follow up one request through those different services, etc. That's with open tracing, which is also now open telemetry. Question about Nils, by Nils, and the security annotations are declared only in the application class. This one, yes. Well, I put them there. Wait, sir, with B. I put them there. Declare roles is picked up on any CDI bean. So what I do, I say, because I find it logic that you say within this application that I'm now writing, these are the roles that that I expect and that I use, etc. Those kind of things. Actually, you can also put them here because this is also a CDI bean. But yeah, I don't, because if you have like 50 or 100 controllers or resources, then where is my definition of the roles? So that's why I put them here. Okay, last thing before the break. And that's, unless there are questions, of course, that's an example, but mainly the steps that you need to do for configuration for a database. I think that I did not miss anything, so let's be sure. Data access. So in our database, we have tables, fields, rows, etc., which are not Java objects, of course. A bit simplistic, but fields are just strings or numbers. So you need to convert how data is stored in a database back to your Java objects, and that's done by what's called the ORM, object relational mapping. And then it's like similar to the mapping between JSON and, for example, and JSON and Java. Here you do mapping between your database and Java. Something which is maybe not from day one, but from day two, then available within Java is what's called JDBC, Java Database Connectivity, which was the way to connect Java programs with databases at that point in, what was it, 97 or something? Because databases were then already in use. And yeah, Java needed to load and store the data there, or has the possibility to store the data there. But you probably know with JDBC, that's a lot of boilerplate, as they call it. You need to create connections, you need to create queries, you need to create statements, result sets, you need to close them properly at all levels, etc. So it is quite low level, as most of the time, if something is new, is invented is so you make sure that it works, and then afterwards people start thinking, hey, maybe it can be done more easily by that ORM standard, because then that low level stuff, you can forget about it. You only need to handle Java objects, which is fine, works well, but it also introduces some challenges. Because your JPA, Java Persistence API, is really working with objects. If you write a query, that means that you're querying Java objects, you do not query databases. So there is, for instance, a translation to a JDBC query under the hood, and if you do simple things or well-defined small things, then that works rather well, but you can have really complex queries, and then those translation tools, they go sideways, and then you have things like the n+1 query problem. You can have issues with caching, or you need to have the need for caching, etc., etc. But let's say JPA is fine, what we are doing. The general idea is even that you use JPA unless it becomes really complex, your queries, and then you should switch to basic JDBC drivers. But what are then the JPA requirements? How can you use it with your application? First of all, you need that ORM tool itself. So JPA is again a specification, so it's not an implementation. There are two main implementations, that's Hibernate, which is also used outside of Jakarta, and for instance, Spring is also using most of the time Hibernate. And the second important implementation is Eclipse Link. They follow that specification. So if you follow the JPA documents, and then you can use it works perfectly with Hibernate and with Eclipse Link. And Eclipse Link is used within Payara Micro. There is a possibility to switch it because on top of that specification, Eclipse Link and Hibernate each have their own specific functionality. They're things which makes them unique, things that go above and beyond the specification, which is fine, but is of course not portable between the different implementations. So if you say I really need something from Hibernate that only Hibernate provide me, then you can switch Eclipse Link with Hibernate within Payara Micro, but that's normally not common, not done. So you of course need a JDBC driver. That's something we all know, and then we need the configuration, and that's as I said, that example will mainly focus on how to do the configuration, all the bits and pieces of the configuration. So the first thing that we need to define is our connection to the database, is our data source. And that's done with what's called a persistent unit. So you can have you have one persistent XML file where you have one or more. So you can your application can connect to multiple databases at the same time. So you can have multiple ones. If you have only one, then Later on, you don't need to specify which unit you're using. If you have multiple, then of course you need to specify which one, but here I'm just creating a test unit and I'm linking that with what's called a data source. A data source is a JNDI name. So that's, again, some lookup directory where you link the name with a certain actual connection to the database through that JDBC driver. So here you have an abstraction of the connection itself, and the database, you only have a name. And maybe some of you know that name, and then they think, well, this is a quite special name, and you will see how I configure that, what the ideal ways of configuring it in Payara Micro, and then you need to use this global namespace of JNDI. Besides the connection, you can have some additional properties. Additional properties about this unit. And what I have here is not always, or it's actually not at all the best practice, because, for instance, I said here when my application starts, it drops my database and it creates all the tables again, which is, of course, a nightmare. But for things like Hello World, like here, that's easy, and it also generates automatically my tables based on the definitions from the ORM tool. So that's the easiest way, but it's no way a good thing to have it in production. There you have to have your database managed separately, and then you can have some scripts, for example. There are tools like Flyway or so that when you start up your application, that checks if your database matches your expectations about tables, etc. And then there can be some updates of table structures, etc., migration script, etc., and those things. So that's more the way to go, or you do it completely manual, that you just perform those scripts whenever you need to perform them, not really linked to the startup of an application with Flyway, for example. But here I'm dropping and creating them, and I put some default data into the in the company and the employee table, so that I have something to show. But yeah, this one is more useful, especially in development, that I have a output in the log of every SQL that it performs, so that I can see that I see what it is doing, and maybe identify that there is a performance issue and that I need to adapt my configuration. Yeah, Christian mentioned, except Flyway, you have also something like Liquibase, which is two different things which are doing more or less the same thing. That's one thing that you need to define. Mainly these properties can be important, and then this name, if you have multiple, because you need to use that name if you have multiple tools, so that it knows which database you are targeting in your query, and then the actual name here, and that is defined here. If you are used to work with Payara server, for instance, then you know that during that install phase, I mentioned yesterday 3 phases. Yeah, you have install, configure, and run. So that during that configure phase, you can create a JDBC connection pool, which has the information about the URL, username, etc. And you can do that also, as I mentioned yesterday, through that post-boot command file, but actually there is a much nicer way with Payara Micro, and that's this data source definition, which is standard. You see, that's part of JavaX annotation SQL. So that's part of the Jakarta annotations specification. And this data source definition, as the name says, it defines a data source. So you need to specify the name. GNDI has a few restrictions there, so that means that I need to go to that global namespace. So, but I say global and I make it clear that it is a JDBC and I give it a name because I have a MySQL running or not running. Let's check if it is already running. If not, then I start it up. Yes, my MySQL here is running. I put it in Docker for those things. It's easy to start up a database and drop it later on without the need to install something on your laptop. I need to specify the class name of the JDBC driver. So that's depending on your server, on your database server solution. So MySQL, for MySQL, that's this class that comes from that JDBC driver jar file, which we will need to define. And then you need to specify the URL, username, and password to connect to the database, and your minimum and maximum pool size, for example. So this is a nice way, and especially because, as you see, and that's something Payara Micro specific, other runtimes don't have that possibility, but Payara Micro allows to read values which are normally defined hard-coded in this, hard-coded only in this kind of definitions, annotations. It allows you to retrieve them through microprofile config. That's a very nice thing, because then, okay, I'm going to put them in a certain file, and then I can say this is the location of my database, so my JDBC URL, and then my username and password. Again, this will be picked up on any on any CDI bean. This is a implicit CDI bean, although it's not explicitly mentioned as at application scoped or whatever, but it is picked up by Payara Micro, and it reads my values externally, which is nice. And then I have a question: can that be made environment specific? Yeah, of course, because as you will see, you define the contents of that file here, and that file can be different in each environment. So it can be different in test and production. And that's the reason why this is so handy for Payara Micro, because if you are just looking at data source definition, you think, oh, that's not useful because you have here a hard-coded string, but Payara Micro and Payara Server also made that it is possible to use some kind of expression, as you see here. So that's the unique thing of Payara. Because otherwise, data source definition is not really useful to have different values in test and production, but now it is. And then, yeah, that ORM tool, the last piece of the puzzle, which maps your Java class to tables and properties to fields. And that's true that this indicates that it is a entity, so that there is a mapping. This defines the name within the database, and this says then that the field name for this property for Java is then ID, name, etc. This is actually not needed, so you can leave that out, because by default it takes the name of the property as the field name. But I have the habit of explicitly defining it always the name, even if it's the same. Because for whatever reason, if I change this to company name and I forget it in the database, then it does not work anymore. But now I see, oh yeah, in the database it was also called name. So either I keep it as name there, or I need to make sure that I also change the database. So that's the reason why I'm doing that explicit naming here, although that is not needed. Of course, you can define column if you want to specify any of the other properties. But other than that, I always specify the name. Question by class, but why you don't specify all data source parameters and pool parameters into persistence XML? I remember that way from GPA with Hibernate. Well, there are two things. Either you specify all the data source properties and pool property here within JPA, but then you don't have what's called a Java transaction the data source. That means that you need to do your transactions yourself. You cannot use the integrated transaction management of Jakarta, which is handy in most cases to do that automatically, as I will show you. That's the main difference. Instead of JTA data source, then you have another annotation or that you need to specify, then it is the non-JTA data source, or you need to use something, I think Hibernate specific, to define it here within the persistence XML. And again, the persistence XML means that it is tied to one environment. So then you need to have a way of changing or externalize those data from that persistence XML. It was mentioned at the transactions, last thing, how do you perform then queries? As I mentioned, you always perform queries on class names. So if for some reason some companies have that, that naming convention, I have a table which is called company table. Then here in the query, here it is the query, I still select from company, because as I said, ORM works on objects. So for the developer, and that's very important to remember, probably you know it, maybe not everyone. From the developer point of view, your queries are not database queries, but are queries against objects. So that means that you have here your object name and not your table name. Same, I think I have it here. Yeah, same here, where a certain ID field, that ID field is then, and IntelliJ reminds me every time if I do that, you see he goes to this one. So this is the ID, and you see it's not the employee ID, which is the name of the field. So always use Java, and then you can select Java objects. If it does not find in the cache, then it goes to the database, etc., etc. That's JPA specific things. I'm not going to details of JPA, sorry for that. If I need to explain JPA with all the details and all the possibilities, that takes on its own, I guess, 2 days. So as I mentioned, mainly about how you use it in combination with Payara Micro, because I believe that's useful for most of you. Criteria queries and criteria API is the better way. Yeah, it depends. You mean instead of where was it, my employee here, instead of using that here deselect, but that you use then the criteria API to also select on fields, on indeed a type safe way of doing this. But if I remember correctly, you need additional metadata for that, which can be generated automatically. But yes, that's a possibility, and that certainly avoids the confusion if this is a SQL of a database SQL or an object SQL, for sure. Other people say then that criteria query, criteria query API is horrible in using it. So I'm not going to say one out, make a favor for one or the other. Yeah, Klaus, for me, both ways are fun. Yeah, it's your preference indeed. Last thing I need to mention is transaction. And that's the reason why I'm using here that JTA data source, Java Transaction API, because then I can make use of this CDI interceptor. It's called transactional. You see it is an interceptor binding. You should know what it does by now. We have seen it yesterday. So that means that we have a round. And what does it do around? That means that it starts my transaction at the beginning of the method, and it commits my transaction at the end of the method, unless there is an exception that occurred, and then it does automatically a rollback, which saves me from doing something like this. Start, not commit, sorry. Begin the transaction, try. Finally, EM get transaction commit, and I need to have a catch also, catch on any kind of throwable, probably where I do rollback, and then I throw it again. So that this annotation avoids that I need to write this kind of structure for each method. So that's nice. There is a limitation, because if you know EGB, and you, I'm not talking about EGB, because in web profile you also have EGB Lite available. So actually, instead of using application scoped and transactional, you could also use something like this without the need to change anything else. So you make it a AGB, and you specify that it's not that one, it is if someone can, if it comes up immediately, you have that transaction attribute or something. How is it called? Transaction attribute, indeed. There you have, as you see, a lot of more options with mandatory, never, require, supports, and not support, and requires new, and those things. So on the EGB level, you have more options what it does when a new method starts. For instance, if your method starts and it sees that there is already a transaction going on, then it can join that same transaction, or it can create a sub-transaction, etc., which is not possible with CDI. If you use pure CDI, then you only have begin and end on the method, which can be sometimes not that you don't want that sometimes, because you might have some methods which need to be in two different CDI services that needs to be handled as one transaction. And then you are still down to this kind of things with begin, rollback, and commit. And then maybe it is better to use EGB, although people, or at least a lot of people, don't like EGBs. But for this kind of, just this simple kind of things, I'm not talking about remote EGBs and those things. They're just stateless local EGBs where you can have the transaction attribute that makes sometimes life easy for more advanced things, which you always have in your application. Question, the annotations for the transaction boundaries can also be on the method level with CDI, right? Yeah, of course. You can also have transaction here on the method level. But if you would annotate each method, which is normally the case, each method with transactional, or at least each public method with transactional, then it is better to just put it, of course, on the class level. But yes, you can do it, of course, on the method level only. And then only this one is transactional and this one not, which is fine because it is a pure select. I'm not changing anything here. I'm inserting something. Good. See, JPA is already a little bit more. I think I've covered everything. So let's have a quick recap so that you have again a high level of what we need to do and what bits and pieces there are. So we define mainly our properties here with the name, and maybe I can show that this name should then go, if you have multiple, should then go here with the name test unit, or if you have multiple databases, for instance, you can within even the same CDI or EGB bin, you can have connection to two databases like this. So first of all, you define your unit name. You can define some properties. I need to revert this because otherwise it will not even deploy, I guess. So let me quickly revert those things. With persistent context, I can execute queries on objects where I have that mapping here defined. And here, an important part, that GNDI name that I've defined, I'll link it to the certain class of the JDBC driver with the config here. So from within the point, from the point of the application, we have defined everything. The only thing that we now still need to do is, where is our JDBC driver? Because I did not specify that here. I'm just using plain Jakarta EE. So I'm not adding my JDBC driver to my application itself. That's one thing. And secondly, where does these config properties come from? And that's through a system like this. I can launch it or not. That does not make much difference. Let's stop me these two and okay, but I probably should explain it here. So we have again Java executable execution of our Payara Micro jar, and this is our WAR file. That's nothing new. What is now new is this adlibs and this system properties. So add libraries, then if you remember what I said yesterday, one of the last slides is that this is unzipped, this is unpacked to a temp folder actually, or a folder that you specify, and with this adlibs, then you can have one or multiple jar files that are copied into the lib directory of Payara Micro. So my JDBC connector can be kept outside of my WAR file, which makes my WAR file smaller. And again, this JDBC driver probably does not change that much. So that means I can put it in a different Docker layer. And that's the reason why I should not put it in the jar in the WAR file here, because that makes my WAR file larger. And again, it has nothing to do with my code, because if I change only a few lines of code, then this is not changed. So that should not be included in that WAR file. So that's the reason why I don't put it here as a dependency. It is possible, of course, to put it as a dependency in your WAR file, but that's the reason why it is not recommended, especially if you're doing Docker. Second option, what you can, the second thing is those files. Either we can define because we can define these values in the environment. We can define environment variables and define the URL, username, and password on the environment, and that gets picked up because MicroProfile looks there also. That's one thing. Fine. I would say that's maybe even the recommended way. But if you, especially if you are running locally and you don't want to pollute your environment with 1,000 variables, then this is an option that you say that after that you have unpacked your jar file, then this file here, which is a property file, is treated as key value pairs and are defined as system properties. You know, system properties within JVM, you can add them and remove them at any time. And they are in effect from the moment that you add them. So since my application is not started yet, then I'm adding JVM system properties, which means MicroProfile config also looks in those system properties and finds the JDBC URL, username, and password. But again, it is also fine to have them in environment, but you see, then I need to create 3 lines for changing my environment, and then it is there polluting my environment, as I said. So this is nicer for my case, but so it works also in production, of course. It's because that file is a file that can be on your disk in desktop production. So that's also outside of your WAR file. So it is also really environment specific, but it's up to you to define how you provide those values to JPA and Payara. And then if everything, I started it, yes, it is deployed, and then I'm reading. You see that I'm reading from the database record 1, which was here, default data. ID 1 was microstream. So if I call record 2, then I get another company. And because I have that debug, I see which queries are performed on the database. I can even have these values also, but that's another property. Question, is there, from Christian, is there a variable for the path where my WAR is unpacked? Because it will not be on my PC in a Docker container. Yeah, there is a value, because indeed, as I said, your WAR is unpacked, but your jar also, and you. Yeah, I get here a lot of errors because it tries to drop tables which are non-existent. Then you get those nice things. But it puts it by default in a temp directory where it is where is here? Here, Payara Micro runtime directory is located in a temporary directory file location, which can be an issue because some operating systems occasionally clean out those temp directories, which mean that your WAR file is gone. Oops, and then you have errors. So yes, you can define where it is, and that needs to be done then by but I cannot put it as last one because that's unnamed. So I need to specify a root dir. Think like this. And this is the path to expansion, let's call it. And then there my Payara Micro jar will expand it and my WAR file will be available and my adlibs will be added there in that root here. And yeah, actually in a Docker container, it is also expanded in temp, which is fine, which is in the writable layer of your Payara, of your Docker container. So it is fine. That's the reason why it is expanded in a temp one by default. Question. Okay, so the property file will also accessible there. Yeah, that property file, if you do it in a Docker container, you need to make sure that it is added to your image, for example, and then you need to make sure that you point to the correct location of that file in your image. Of course, that's I think that's obvious. Okay, that's what I wanted to talk about before the dinner break. Shouldn't say lunch break. Dinner break. Any other question first, maybe, to make sure that we have nicely covered this part, because then after the break we will start with MicroStream. Okay. Questions can also be afterwards, but I don't see something come in, and as I said, I would like to see the option in Zoom that someone is typing on it. So again, 1 hour break. So we start 15 minutes after the hour again for our second half of our second day, which is also the last half of the training. So enjoy your dinner if you have dinner, and otherwise I see you again in an hour. So I hope that you are all ready for the last few hours of this Payara Micro training. Before the break, we covered the Java Persistence API. Is there any question about that topic that came up in your mind, or do we continue with the next topic? Maybe I can already show that question around that OpenAPI code generator. I thought that there was a online website where you could do it, but maybe I was wrong or I did not find it yet. But this is the project and also the documentation on how you can use that OpenAPI code generator. And one of the frameworks, because you see there is a lot of frameworks supported. One of those is, as I mentioned, MicroProfile REST client. So that is available. And then there is here a description further on downwards. So you can either add it as a Maven plugin or Gradle plugin, or you can do it on the command line, so that based on that open API document that you can generate then those Java classes that are capable of calling that those endpoints are described in that document. So that was one of the, it came up, I think, already twice or so of code generation based on that open API document. So yeah, that is possible, and you can have a look at this GitHub repo for more info. So open API code generation. So that's one thing. And then we are going to discuss MicroStream. And yeah, MicroStream can be used as an alternative for reading your data from an external system, database or NoSQL solution, or any kind of solution where you read your data from, and because your Java process needs to store your data somewhere, because otherwise, yeah, it has lost all the data when you stop your process. Then, so in our previous JPA example, we have used database, tables, fields, etc. In general, there are a few downsides, a few issues related to using databases or an external system in general, which is not a problem of the database itself, but just how you are using a certain system, how you are the setup of your environment. So databases itself or Hibernate are not a fault of that. It's just if you have an external resource, that means every time you select data from a database, you have that latency that can be small, that can be larger, the latency to retrieve the data from that external system. With the database, you also have that conversion. You have that ORM tool, which needs to map those basically strings and numbers, as I said, to objects. It needs to parse the queries or create that criteria query through that criteria query API. It needs to parse that, it needs to analyze them, it needs to see if it's in the cache. If not, it needs to load the data, etc. So all that can be quite time consuming for the developer to write and to learn, for example, all the entire JPA functionality. I mentioned that I probably need something like 2 days to cover all aspects of such ORM tools. And also at runtime, it can be slow due to those things that I mentioned. And having those caches is not because that adds an additional overhead. It tries to mitigate some of the performance issues by having your objects, your Java objects already in memory, so that it does not need to look for the data externally and create them as a Java object again. So yeah, and then you see that the impedance mismatch, that is the term that indicates that there is a more or less completely different way of storing information, the relational way or the object the object way with object graphs. And yeah, it is possible to match them. The ORM tools match them, but it is sometimes a difficult match, and it can give you some headaches in tuning, in making sure that your application is performant. And the idea that then came up by the people of MicroStream, started around 10 years ago, was if those tools like Hibernate or JPA in general try to solve it by putting your data into memory in a cache already, why not go one step further and saying that your object graph or a certain object graph, you will see in one of the examples, that a certain object graph in your memory is the database. So don't see the external storage, because you also need an external storage, but see the objects in memory as the primary source for your database, which means that your data is super fast accessible through standard Java, getters, stream API, if you want to search through collections and those kind of things. And we need to store the data externally, of course. For the other reason, if our process stops, then we would have lost everything. But instead of using a specific format of the external system, like the NoSQL or JSON or whatever, why not store it in a format that closely resembles the Java object, and that is a serialized binary data format then. And that binary format is stored on disk, or in a cloud storage like Amazon S3, that's also supported. Later on, people came with the question, well, we still have those databases and we still need them for other purposes, so why not store it as a blob in a table? So then the possibility was added to store that in a table as a blob, not as fields, etc., but pure as a binary serialized format of your Java object. And then when your process starts, it populates your object, your object graph, your heap with those objects, and you again have all the data available as it was when you stopped your process. There are a few other things that need to be solved, like can I store everything in memory? How can I store that terabytes, etc.? So I come to that in a moment, but that's the general idea of MicroStream. Started like 10 years ago. It was improved over the years and open sourced a few, I think 2 years ago, 2.5 years ago, open sourced. So about that open source version, I'm going to say a bit more. And yeah, the end result is that it saves a lot on CPU power, because those binary conversions are much faster than performing queries, etc. It also simplifies your architecture, because most of the time you don't have a database or an external system anymore which stores your data. Something like an S3 bucket is enough, which is of course much simpler than an entire database, and faster through those in-memory queries. You can store it, as I said, in a database. Most common databases are supported. There is NoSQL storages like Hazelcast or Kafka, even MongoDB, and cloud object storage solutions like S3, Azure Blob Storage, or Oracle Cloud, for example. And of course, just plain disk. That was the first ever the data storage location. And MicroStream is a rather large system in the sense that it has 20 or something different modules. But in absolute terms, it is much, much smaller than Hibernate because it needs to do quite less functionality. You don't have all those kind of queries and mapping hierarchies and parsing of SQL queries, that caching, primary, secondary cache, and all those things. Basically, it is a serialization framework on steroids, maybe, because it has a few additional functionalities. So you see there in the middle that serialization is the basic functionality, the cornerstone on which that entire system works. It is a custom serialization and not the JVM one for multiple reasons. Today, there are still two reasons important. That one is that you need to be able, or they needed, my MicroStream wanted to have the possibility to store any kind of object, not only those which are marked as serializable, which is required for the Java one. And the second thing is that it needs to support some kind of data model evolution. Just as with the database, your fields, that there might be field rename and edit field, new tables, restructuring. Same happens with your Java objects. You do refactorings. So your old data should not be lost, or there should be an easy way to keep those data and map them to the current version of your Java object. So that are the two main reasons. The third reason, which is now less important with JDK 17 and the security filters that they have added there for the serialization, but it is also by default secure, because there is no method execution at all. So no constructor, no other method is called. So that's more secure than the standard one, but that's less relevant these days than it was 10 years ago. Then based on that serialization, there is that persistence ID, and there is a version for the JVM. So it's not pure Java, nor not Java alone. It works with any JVM language, and there is also a version for Android. There is that legacy type mapping, as I mentioned, that's for that data evolution, which is required. And you can visualize your data through a REST interface and a browser, a storage browser, so that you can inspect those things mainly during development, so that you can see if it is stored and that everything worked. From the side from storing, then you have what's called that file system abstraction. So that the engine can write to an abstraction layer, so that it is possible to support disk storage, database storage, cloud connected storage, etc. There is also a garbage collector thing, but I come to that more in a moment, what that exactly means. So the idea is that I run through a few things, basic things, the three basic things of MicroStream, and I also show you the integration which is possible with Payara Micro. So there is a CDI MicroProfile config-based integration of MicroStream within Payara Micro. So first of all, MicroStream comes as a dependency to your application. So there is no real external process running as like a database. So there is nothing running externally that accepts your data. So everything is added within your application. And that means that you need to add basically one dependency. That's this one. If you are using some specific additional functionality, you need a few more, but this is basically one dependency that you need. Current version is version 7.1. And if you look then, okay, there are more here, but if you look here in the list of what is then brought in transiently through that one single dependency, then you see that there are only dependencies from MicroStream itself. So we don't bring in something like Google Guave or Apache Commons and those kind of things on purpose, so that you don't have any kind of clashes between versions that you require or use within your application and that MicroStream might need to use. So utility methods and those kind of things, they are all implemented by MicroStream again. That's okay, maybe duplication, but it probably saves a few headaches by the developer to match everything in one project. One exception, that's SLF4J, the simple logging framework for Java. Because we want to have some logging available about standard things. When you will see the storage manager start or there is some actions performed, or low-level debug things when you get very detailed information of what's going on. And don't want to create some new logging framework, but SLF4J has a very good backwards compatibility system. So that means any version of 1.7, we're using the .36 version here in that version 7.1 of MicroStream, but any 1.7 version is compatible. So the implementation, like here, output the log just to the through the JDK system, but you can use log4j or logback or whatever. But that does not need to be exact the same .36 version. So any 1.7 version would do. So that's not really a problem that we bring in that API there. So one main dependency, there are different ways of configuration. The builder-alike system, you will see the example, requires this configuration dependency. And then for the SLF4J, I have chosen the simple one, but feel free to use whatever you like in your application. And then there is something for the serializer specific. It is most of the time either these two that you use, or if you only use the serializer, pure serializer framework, then this is enough. But because I have those two examples in one application, I have them both here in the same Maven structure. What else than a hello world? To show you the concepts, give you an idea of the concepts. And the storage manager is the one who is responsible for, and that subsystem is responsible for reading the data and writing the data, at least from a high level, from the point of view of the developer. Internally, it is delegated to other systems. And by starting the storage manager, then you can link, and that's the idea of the storage manager, you can link a object graph with a location where you want to store your database. As a secondary source, as I said, the idea is that you are using your memory as your database that you query. So here it is binary stored, so we need to specify a directory. And this is one object of our object graph. And because an object graph is a connected set of objects, as you have seen in the image on the slide, you have all dots linked by references. That can be a large structure, that can be can have circular references. So you need to start somewhere at a certain object, and the system will look at all the possible links and will store all those. Here, as a start, I'm just going to put a string value in my object graph. So it's just my object graph, my root itself, and a string value. So let's start small and expand on things. Interesting thing, I can, as I mentioned, we don't execute constructors, so I can throw exceptions and it will still work. So after we have created that link, then we can use our object graph as a normal Java object. So we can set a value, we can read values from it. So we print out here the content of our database, which is then this toString method, which is executed. And whenever we change the value, then if we don't store it to that binary in a binary format, then we would have lost the data. So we need to ask for the storage manager, store me that this object graph, which is now changed, come to that later, what it stores exactly, but it makes sure that we store then this hello world with the current date there. To the binary format, you can explicitly ask for a shutdown. That's through that try with resources block. It's actually not needed. Once it is stored, the JVM can crash, and it will still be functional. There is a question of, can we relate a location with Docker containers? Yes, I'm thinking where I made that example, but if you, in short, you can just define a directory. Okay, this is now target and it's of course not very useful, but you can define a directory. And for example, with Docker volumes, you can make a mapping from that directory where you're going to write the data. You can map that to some location that is persistent, which is durable, and then you can map, you can link your Docker container with that directory, and that you can start over again the next time where you left the data. That is possible. I was thinking if I had it somewhere online as an example, but probably not. That still, I was working on it, but I don't have that example in a GitHub repo yet, I think. But with standard Docker volume mappings, you can map that directory to any location. So initially in the target directory, there is nothing. So that means our database is empty. It will be NOLL, except that we have this blank value here then, because that's the default. We have assigned that. And we set it and we store it, and then we can run it over and over again, and you will see then it will change by each run that we do. So first time it is empty. The content externally was empty. We have written this value there, and it's 41 minutes, 17 seconds. So if we run it the second time, we actually initialized it to blank, but then this command, this statement, or one of the statements within this method, of course, will override that value with the data which was serialized, which was the data which we set the previous run, 41 minutes, 17 seconds. That's the only kind of magic what happens with the storage manager. And MicroStream, for the rest, everything is very transparent, very straightforward, no hidden tricks, no proxies, maybe one little proxy, but I come to that later. So it is quite an easy system to understand. 38 seconds, it was then the second time, and then we have written now again a new value. In the target directory, we have that data, I specified here, and we have a channel. Come to that in a moment, and here that file is that binary format, so yeah, it's binary. But in that binary format, we don't write any kind of object class, object property names. We only write these identification numbers. And when we read, we scan the binary at startup, and then we see, oh, we encounter number 1,067,000, and then we see, oh, that was the data root, and so that we know that there was a string, so a string property called value, etc., and so that we can analyze the contents of that binary data again, and then we can map it to the class that we have now, data root. And I don't have that example here, but if we would rename this, let's do it properly. I rename value 2. Then that would still work. That's one of those nice things, because it identifies that I have a string with property value. I have now in my Java class a data root with one string property, but it has another name. But yeah, you can also explicitly ask for confirmation or that you stop your application, but by default it tries to match those things, and it sees, oh, you had one string which called value, and it's now a string value 2, so the name or the names are almost identical, same type. So yeah, you have renamed that, and so I'm going to map that automatically. Which means if I run it this now again, it was 42.35 seconds. And I have clicked it here. I did the debug here. It was, and now it loaded the old data with my new class structure. Well, not really structure, but okay, with a changed one. How does he handle those things? You see that he has now created for that same class a new identifier, because you have now something with value 2, and he maps that automatically when it starts up that these are both there. So in that binary file, you have now some data, because it keeps a bit of older data which is cleaned up. Because every time you store something, when you save something, it is not it is not overwriting your entire thing, it's only writing the changes. And it adds them at the end, something like Git does. So he adds the changes, and that means that you have in that same file here something with the old version and the new version. And then that garbage collector that I mentioned, that will eventually clean that file up so that, yeah, it does not grow indefinitely, so that you have reasonable file sizes. So that's the Hello World one with that data model evolution already a bit. There is more to tell. There is no more training of MicroStream this year. If someone would be interested in that, there are also 2 days trainings around MicroStream, but watch out, either the newsletters or the announcements, probably in February or something, or March, there will be again 2 days, and then you get much more detail about things that I condense now here in 1 hour or something. This is normally not the way to configure it. It's nice for a hello world type of thing, but most of the time it's not enough. Because I said there are 20 subsystems. Actually, each subsystem is an interface with a default implementation. So you can even change every little piece of microstream or adapt it to your needs. So you need something much more sophisticated than just this one line. So the classic thing of defining the storage manager is something like this. That builder pattern, which requires that configuration dependency. And yeah, again, you set there those basic values like the location. You can also set now the channel count. And what is the channel? A channel is a thread which is responsible for performing the serialization and writing the data. So the I/O, the conversion from Java objects to binary, and the I/O actions, that's the responsibility of a channel. Since I/O that can take a bit of time, so most of the time, if you can do those things in parallel, you can increase those things. So with 4 channel counts, then you have 4 threads. If you have then more classes, of course, with that hello world that we had here, that makes no difference at all. If you have real world thing, data with a few hundred megabytes of data, for instance, then of course having 4 channels, 8 channels maybe, needs always to be a power of 2, so 1, 2, 4, 8, 16, 32, etc. Then that makes it the difference, and then that can then go faster. I set the default value here as 4. And of course, this should not be hard-coded, but coming from configuration values, but that's something that you should know, that you should now know how to do it with MicroProfile config, for example. There are other things that you can set here, which, for instance, here that the directory for channel 0 is called channel_0, but actually you can specify that channel underscore value by setting the directory prefix. You can define how large such files can become. Is that 1 megabyte? Is that 10 megabyte? Whatever. You can define here the maximum size. You can define the file prefix and the suffix. Again, the suffix is dot by default, etc. So you can define a lot of values, not going to go over all of them. And once you have those configuration settings, you can create what we call a foundation. And a foundation is taking into account these values, but preparing those 20 subsystems, preparing the default implementations of all those interfaces. And then you have the possibility to customize all those different things, most of them through an on-connection foundation method, through a callback. There are a few subsystems that needs to be configured differently, but once you have that foundation, you can do the final tweaking or whatever changes that you need. You also set that root here at that point on that foundation. And then you create that storage manager. And after creation, don't forget to start it. I could place a start also, of course, in the creation here, but I've called the method create. I've called the method with the name create storage manager. So that's the reason why I should not have start within that method, just pure based on the name. Here, my data storage is a list of products. It is still a small thing, of course, but that product is again, a simple class, simple Podio, no annotations, no implements, no extends, no whatever. And you can use any kind of object. So you have seen string, you can use third-party classes from third-party libraries. There are a few restrictions which cannot be serialized, which probably makes sense if you think about it. Things like a thread, a socket, things like input streams, etc. Those are classes, but they are all linked to a resource, which means that if you would deserialize them back from the binary format, yeah, that socket, for instance, is not opened at that moment, and there is no link between them. So that's the reason why you cannot serialize those classes. Lambdas is another real lambdas, not the, if you have functional interfaces where you create a normal implementation for, but if you write them as the lambdas, that is also a thing that you cannot store, for the simple reason that within the JVM itself, you cannot identify them. They are created like, yeah, that's what's called sometimes that syntactic sugar, but in a way that the JVM itself has more or less problems of identifying what the exact nature of that and the content of that lambda is. But lambdas, most of the time, they don't keep data. So in our opinion, that's not a great problem, a great loss if you cannot store them. Yeah, I load my products here, so I'm loading a few products, and this time it was also correct in the previous one, but I am only storing the list of products and not the root itself anymore, because the root is not changed. So if you look at our root object, we have an instance and we have a list, a variable which is a list, but yeah, that's even a final object. So the object itself can never change. So if we would ask for the storage manager to store our root object, the instance of data storage, then it sees that you have here a list, fine, but it sees that also that it is not changed because it keeps the old version and the new version, which you try to store. There's the new version, but he also keeps pointers for the old, the version that he loaded to see if it is changed, because if it's not changed, he's not going to store it again to that storage to save processing time, to save especially disk, because if you have 100 megabytes object graph in memory, you don't want to store that every time if you just changed one name of a customer that has ordered something, for example. But it also stops there if it sees that this list is not changed, because in terms of pointers, in terms of references, then it also does not look into that reference. So it does not look into that list, which means that if we add here products, if we would ask to store the root, then it will store actually nothing, because it stops at that list and does not see that the products in the list are changed. So for that reason, the general rule is store what is changed, and what is changed here, well, the items of our list. So we need to store the list. That is sometimes a bit confusing for some people. Some people have pick up that rule easily. Others have needs a bit more time. Myself was one of those people when I started some time ago with MicroStream. I sometimes picked the wrong thing, and then I did not have the data correctly, but it's something that you will learn rather quickly. That's not that difficult if you keep that in mind, store what is changed, and most of the time you see on which object you did a change. Here you do an add all on the products, so that means that you need to change this list here of products. I can run that. The first time it will be empty. Number of products will be 0. The second add, then we add those 4 products, and then that will be 0.1. I have here the way of that's what we call the query language of MicroStream, which is pure Streams API. How you can find something for example. And then there were 4 products, and the second time it's not loading them again, but he still has those products from the previous run, and you can print them out, those 4, and you can still find it, of course. That's the other important things around MicroStream. And then the last thing that you need to know, but again, it is really condensed, is what's called lazy loading. Most of the time, and that's of course the optimal way if your data can fit into memory, but that's not always the case. Maybe there are more cases where it will not fit than there are cases where it will fit. And for those situations, we have that lazy interface here, where there is of course an implementation. And with lazy, when it loads the data and it encounters as type lazy, like here, that means then that the actual list, which is referenced within that lazy reference, is not loaded into memory, but that lazy acts as a kind of proxy. So you have the lazy object, but it is actual empty. And when you access the lazy.get methods here, then it will, if it's already in memory, fine, then it doesn't need to do anything, but otherwise it loads the data at that point from your storage into memory, and it returns it from the get method. So by using this kind of structures with lazy, and I have a few examples and I come that in a moment, then you have the capability of having already a reference and proxy available that it can load those data, but it keeps the data out of memory until you actually need them, which means that you can have terabytes of data, and you can have a Java process which runs maybe on 512 megabytes if you are using that lazy intelligent. Because this gets loads it, but this clear prepares it to be removed again from memory. We are not actually removing it because that's the job of the garbage collector, and yeah, you can only say that your object is ready to be garbage collected. And with this lazy, I'm not sure if it's in the description here, but this lazy, the implementation of this lazy is using weak references. So that means that even if it's not explicitly cleared, but clears helps it so that it removes all pointers to it, so it can be removed during an incremental garbage collecting run. But because it is also a weak reference, that means that if your memory starts to become a problem, then the garbage collector can remove it at any time at will. You as developer, you always use the get method, which means that if it's gone, you just load it again afterwards. This clear is just to make it unreferenced by any kind of object, which means that the garbage collector can remove it more quickly and not only during a full scan or a critical run when your memory is almost at 100%, when there is no space anymore to allocate a new object. So this, with this clear, you help to keep the memory in balance. And that means that you load the data that you need, and afterwards you say, I don't need that data anymore, and I can clear it. Typical use cases for that is, for instance, you have a list of few 100,000 customers, and for each of those customers you have orders. That means that you have maybe a few millions of orders, and putting all those orders in one gigantic list means that you always have them in memory, and searching through them becomes maybe a problem. So then, the same way as you do with the database, you do some kind of indexing. Here, indexing is the Java way. You can use some kind of indexing by using a map, a hash map, where that string ID is your customer ID, for instance. This get is on the map, so it returns this lazy list of orders, and this get is on the lazy, so that loads your list of orders for that specific customer. And when that list is no longer needed, you can do on this get of that map, you can do a .clear instead of .get, and it is can remove from memory, and you only load the orders for the customer that is part of your user request. So if you have a post saying, oh, I have a new order for customer 123, you can quickly load the orders for customer 123, do whatever is needed, everything is done, you clear it again, and you free up the memory, and that's the way how you can handle terabytes of data with maybe 512 megabytes of heap. Of course, it is slower because you always have loading and unloading. That's, of course, obvious, but it is still much faster than with the database, and we have proof for that. We have done a lot of performance testing, and even with that lazy loading, you can have an improvement of 10 to even 1,000 times, depending on the database queries. Another way is, you have that lazy list of orders, but you might want to make statistics for each month. You want to keep a list of, you want to calculate the number of orders and the total net value that you have made in that month, for example. So you can also put that same order in another map where your key is something that is based on a year, the combination of month and year, and then you can only load those orders for that specific month, and then you can process that, and you don't need to load all your orders from your entire business, which is already working for 10 years. Like I said, due to that no mapping, no and that query things, we sometimes achieved a factor of things that went more than 1,000 times faster. Coming from, I have that examples coming from like 3 seconds a query that runs for 3 seconds with JPA and Hibernate, that now runs in something like a few milliseconds. So with that lazy, it's yeah, I tried to do some things with the heap available heap memory, but yeah, as you know, garbage collector cannot be commanded. You can ask for a garbage collection. I think I did it here. Here is system, but that's only a hint. So unless you already have some memory issues, then this will just be ignored. So you can play around with the example, and you know everything is on GitHub. But yeah, you will see that that clear sometimes does not result in a decrease of memory usage, because it is not really doing any garbage collecting at that point. Question from Klaus: can you show how you would implement MicroStream with JTA and especially the rollback of a transaction? Well, there is no really transaction, in the sense that you have more or less a transaction of when your data is stored. So let's take this one. Nope, that's my data storage. This is my main program. Sorry, I'm a bit lost. Here, this is stored, and this is kind of transactional. It happens or it does not happen. Suppose that you have X number of different changes that you want all to be happening or not. Then you can do something like this. Create lazy storer. And then on the storer, you also have a store method. So you can say, store me object 1. Other statements, other methods, other class, whatever. At another point, you do here again a store, but an object 2, and here a store on object 3. And at this point, you say, well, all these 3 changes now needs to be flushed to disk, to your external storage, and that's then here done through that commit. The store on the storage manager does a commit by default immediately. So if this method returns, the data is already in that external storage. So if you do not want this data already in that external storage because other things should be kept together, then you can use this kind of technique, and that lazy storer is then the one that I specified. Those things. And if something goes wrong in the middle, MicroStream handles, that's a follow-up question, and that's then handled by a backup. If you have here our configuration, create storage manager, you can also define a backup directory. So if it fails, if the writing fails to the first, and that by backup directory, again, can also be a cloud or database, it can be any kind of type. So if something happens during the writing of that first one, then your backup directory still has a intact one, a non-corrupted version just before your storage started, your storage action started, which was interrupted and made your storage corrupted. So then you have this backup directory to go back. This entire, maybe that's another question which comes up, this entire storage manager is not multi-threaded, it's single-threaded, because you can imagine, and that's also a restriction from Java, if you write from multiple threads to one single file, you have guarantee a problem and a corruption. Just try for fun, create 2 threads which write quite a lot of data, so pure text, to the same file, which is opened by 2 different threads and writing at the same time. Your data at the best, in the best scenario, will be a mixture of those 2 threads, not one after the other. And that would, of course, totally ruin things if they are binary, where you have first a length bit and then saying, and those kind of things that would ruin your storage, of course. So MicroStream here in that sense is single-threaded. That sounds strange, but actually your database itself is also single-threaded. Every and most databases serialize each update and do it one by one. Also to avoid those kind of corruption, also to avoid those things that if you write at the same time, which would makes it corrupt. You mentioned, can you use MicroStream with JTA? No, because you don't really have a transaction management system. And yes, you need to take care of some things yourself. For example, because if you add, you change multiple objects and then you realize, because there happens something, that you need to undo things, well, then it's up to the developer to undo things, or there is a way of, but that's not a single line, but it might come as a single line. We are thinking of implementing that in the storage manager itself, of reloading subgraphs of from your system, so that you can get your data back from your storage, so that the things that you have changed in memory, that they are, that you undo them, so that you do a kind of rollback. Does that answer your questions, Klaus, what you have about transactions and corruption, etc.? And indeed, Christian, the limitation is how much RAM you have. But with that lazy, where is it here? Lazy. With that lazy, you can control so that not everything is loaded at once, but only, as I explained here, that only the orders of a certain customer are loaded and not your 3 million orders that you have in total there. So you need to think more, probably, and you need to spend more time in designing your object model and how you will use your data than with a database. In a database, we are a bit lazy in that sense, that we just create a table and then it's up to the indexes and whatever and the DBA to make sure that it works in a performant way, even if there are 10 million records. And then you need, Oracle has also theirs, you have partitions and whatever things. So as a developer working with a database, we are probably a bit too lazy and just say, oh, it's the problem of the database. Now it is more the problem of the developer, that, or the one that designs the basic ideas of your object graph, to think about what structures do we need, like something like this, to efficiently access our data. Klaus also mentioned that there might be consequences related to the amount of additional logic you need in the application layer. Yes, you need more things in the application layer because you don't have a database anymore. You don't have any external system anymore. You just have a dumb file system where where things are dumped, but that's not a intelligence. system anymore. It's not a system that has some logic. That's correct. And after many years with database, etc., if something unsure because of no sequence transactions, etc. Yeah, it's a different world. And we have seen that a lot of developers, although we are Java developers, are actually only focused on how does it work with the database. And we are writing our Java applications and how we develop purely based on the database, not what is optimal maybe for Java, but what is optimal for the database. So that's indeed a quite maybe a change in ID. Again, I'm not saying that MicroStream is the silver bullet and that everyone should throw away their database tomorrow. But there are cases and there are customers, for instance, that reduce their environment. They had a clustered setup of 3 servers with 1 Postgres database. And now they are running just 1 single machine, no longer clustered in 3 times. So they have downsized their system by a factor of 3, and they can still handle the same amount of users. But maybe not your case for your case, or maybe it's much more difficult for your case to switch. I totally agree with that. I will see if I have compile errors because I changed a few. I was playing here. Yeah, I feel compile errors here. So let's go back to that. That serializer. That's something that you can use standalone. Then you have a lot of those subsystems that you are not using. But you can serialize. In this case, it is a circular, an object graph with circular references, which just as an example of a serialization example, which is non-trivial. We have a boss with a few employees, and there are links and back from the employee to the boss and as a manager, etc., etc. So you can create then that serializer based again on that foundation. That should sound familiar now. You send it to a byte array, and you can deserialize, and you have again your boss with his with the employees directly reporting to him. And if we can print it out, and we can see that the structure is still the same, and we can do even tests to see if they're that they are the same object, yes or no. So no, because it is completely new serialized, so they will be different, but the equals will still be will still be true. So that means the data is unaltered. Same objects are false, so the references are not equal, but the equals methods shows true. And if you compare this output to this output, then that's of course identical, because the data is identical. This might you might use this in some project. It is used as a more or simpler or more advanced. It's the way how you look at it as a clone object. So if you sometimes need to clone objects in Java, that can be quite cumbersome. With this serializer, that becomes, of course, a piece of cake. Also, because you don't have any requirement and restrictions, and with clone, you need to again have that those interfaces. So that's, as I mentioned, really short intro about MicroStream itself, about what the ideas are, and maybe you have then an idea if it's suitable for you or not. And if you think it's suitable and you want to know more, please contact then the people of MicroStream itself. They are happy to help you with your questions, to have a discussion to see if your use case fits with MicroStream, yes or no. I'm going to, if there are no other questions, of course, but if there is, please type in. In the meantime, I'm going to tell a bit about the integration there is between MicroStream and Payara Micro. There is an integration for Spring Boot, Quarkus, Helidon, Micronaut, etc. It's integrated in all major runtimes, so also included for Payara Micro. And yeah, there you need the integration. This one is specific for CDI. You have integrations dash Spring Boot, integration dash Quarkus, etc. Which brings in then the actual classes, external, yes, it is external. So you still have those same classes as you have on that command line, as you've seen before. But now one additional thing is that CDI one. And what does that integration does? Well, one thing is that you can now define your directory and your channel count, etc. It will now be looked up as keys within MicroProfile config. So it's using MicroProfile config for that, so that it is easier in a way to define it and make it environment independent, so that it works in test and production. Just change again somewhere where MicroProfile can read them, read those data. The other idea is that the storage manager, you have seen here the storage manager, that you normally are responsible for creating that storage manager and setting that up. So now that's the responsibility of that integration. You have specified here the config, and you also have two types of CDI beans. I don't have that in this example, but there is a larger example on GitHub. Is it there? Yes, it is there. I think it is there. Let me look for it. I created all those patterns alike. It should be there, or it is here, the MicroStream CDI patterns, where you have, as I said, you can customize that foundation. So that gives an example how you can do that. You have etc. You can have even multiple storage managers at the same time, etc. So all those examples are here, so you can check them out. And yeah, since the storage manager is now maintained by that integration, it is also defined as a CDI bean. So that means that here in my repository, I can inject inventory, which is actually my root bean. So by annotating my root class with add storage, I make it the root bean, which will be picked up by the storage manager. That's one thing, but also that you can inject it then. So as you have seen, I can inject it here in my repository and I can access my data. So that's a bit to keep the patterns alike, similar to other data access things. You can inject it there. And as you have seen, the called the persister, but let's call it to be consistent in types for what you know for this introduction. You can also inject the storage manager itself so that you can call here the store. Persister is the actual subsystem who is responsible, but of course you can use the storage manager also. So that's the integration. All our integrations with all those frameworks are working in a similar way. They all have this annotation. So also if you are, some people, if I remember correctly from the introduction yesterday, were more familiar with Spring and Spring Boot. So you also have there that same storage annotation. So you can also use that, and there you can use, of course, auto-wired, and those two, there is a uniform way in all those integrations. That's a quick overview, as I said, from MicroStream. Not sure if there are any questions. If you want to have those 2 days training, and the basic training is also 2-day training, then watch out. As I said, probably February, March, there will be also those MicroStream trainings. The last one was 2 weeks ago for this year. So in 3 months, around almost every 3 months, we do those trainings. Integration testing with Docker containers. So before I switch to integration testing itself, maybe I'm going to tell a bit about how you can use Payara Micro with containers, what the different strategies are, etc. And then after our 10 minutes break or so, then we really are going to switch to integration testing, which is an important and nice thing how you can test your applications. So Payara Micro provides for each release, and for JDK 8 and 11, etc., they provide official Docker images. So you can say from that one, give me that basic image, and then, for instance, here, copy me the WAR file that I have generated and copy that to this directory, which is a special directory which is scanned during start of your container to see if there is any .war file or any .rar file, resource application. If that's the case, it automatically deploys it when your container starts. If you start working with Docker, that's at least my experience, this is probably the most easiest way to create your Docker image, and by then running Docker builds, make sure that you link to that Docker file. That's the location itself. This is a relative, so that would work, and you specify a name, demo.myversion 0.1. So this is, although it is 2 different steps, my Maven or Gradle is building my WAR file, and then I have an additional step which builds my Docker image. In CI environments, you can have there also an additional steps. You have there traditionally a sequence of steps from checkout of your code, compiling them, etc., etc. So that is, if you ask me, the most basic, simplest way, but also to understand what Docker is, because yeah, Docker, it's, at least for me, it sounded simple, what, like 7-8 years ago. If you dive a bit deeper, then it is rather complex. So by just sticking to that basic build files, that is probably the easiest way in the beginning. Everyone has his own idea about it, of course. The next step that you can take is that you can use one of those Maven plugins to build your image as part of your Maven build. And there are several of them. You have one of them is Fabric 8, where you define that build file that you have specified here, where you define that build file through that, yeah, the classic things within Maven, through that configuration tag and a set of XML then. This does exactly the same as that previous version, but it helps that you know how you write it in a classic build file, and then you can follow this kind of structures more easily than if you immediately start from this and don't know that there is a Docker build file and how that works, and so that's a much larger step and much more difficult. So here, yeah, you have an image, you give it a name, you give it a tag. Previous one was demo version 0.1. That was a version, the tag number. Here it's also. This is my from. That's probably not the most difficult part, but then with these assemblies, then you define what of your output, what of your target is copied to your image and where it is copied. So here I say my artifact in the target directory is copied to that directory. And with that, with those descriptor ref and naming, etc., yeah, sometimes that that confuses me. So sorry. If you are more familiar probably with these kind of plugins, then you can work more easily with it. So sometimes it is, especially if you have then, because this is now a really simple Docker file. I have seen with customers that they have Docker files which spans hundreds or so statements, so there it's a huge file. If you would try to put that in this kind of XML structure, yeah, well, that's a nightmare, because I don't know, you have maybe 500 lines of XML just defining your Docker build file. So in that case, it might be easier to, okay, use that XML, but refer to an external Docker file. And then you have here source main Docker, where you have the Docker file. And again, you have a simple from and a copy. The only thing what is a bit tricky is that it's now no longer target, but it's called Maven. And then this artifact is then refers then to this demo file, and it is now in a directory called Maven. And you probably find that out if you are running it, because then you see under the temp there, no, not the temp, where is it, in build Maven, and you see the demo. That's actually how I found it out the first time, that it was not target, but it was Maven that I needed to put there as a directory, just by looking at the structure that was generated in the target directory. But it can help you if you have a real complex Docker file. I'm not saying that you should have such a complex Docker file, but maybe your application requires it. I don't know. And then this option might be easier than defining everything in XML. That's Fabric 8 plugin. It's not really stopped development or deprecated, I think, but it is going slower now because actually the same people have now started a initiative under the Eclipse Foundation also. So not only Jakarta is there, but you also have other initiatives, and the JCube is, although it is most of the time just one vendor, in this case it is Red Hat, they have something under that Eclipse Foundation, vendor neutral, more or less, so it should work with everything, and those basic stuff that works. That's also nice, but JCube can also generate Kubernetes deployment descriptor YAML files, which is a nice thing because they might be quite difficult to get it right. Not only because you have YAML and one space can make a difference between it works and it doesn't work, but there are also a lot of names and references that needs to match, etc., etc. And so that can be, especially as a Java developer that does not do those things daily, it can be a challenge to create those. So I tried that, but sadly enough, it did not work. I don't know why exactly, but it creates that those YAML files, like for instance, it creates something like this, which seems to be more or less okay, at least from the point that I could understand it immediately. But when I tried to deploy it to Kubernetes environment, then yeah, it does not give me what it should run. So I don't have that application then available as a service with pods. So I did not spend hours on it, only like an hour, try to figure it out what went wrong, but yeah, I did not find out yet why it did not work. If it's purely for generating Docker images, there it works, because as you can see, it's almost identical, and that it was highly inspired on Fabric 8. You have almost the same concepts of target assemblies, and you can also use Dockerfile. You see there are slightly different things, and they are not exactly called the same, but that works. Only the Kubernetes part, that I'm missing something, probably. That something that I did not get to make a working version of. Are there any questions around creating Docker images? I did not go into those layers anymore. Maybe I should show one thing. Maybe not a lot of people know that. Wait, I'm going to use this Docker image as an example. That's still the older one, but that's not a real problem. What a nice tool is called Dive. Not sure if everyone knows that. You can install that, and that analyzes your Docker image to see if you have optimal layers or not, and what is changed in the layer. And if you have changed, if you, for instance, added a file in one layer and then updated that same file in another layer and then maybe deleted in the layer on top of it, which means that you have all those data there, but yeah, actually that file is deleted, so it is of no use anymore. And you can here see on which layer but it is a bit changed now. I see the latest version. Because before you nicely got a indication of how efficient your layers were and which statements were executed for each layer, and then you could see, oh, my copy, etc. It was nice, it worked, but it masked a file underneath, etc., and those kind of things. But it changed now, the latest version. So there this was just too small. So you see, I have my different where is it? I should be able to put here. Yeah. So you can see my commands, for instance, in that within that Payara Micro image, they start from a certain image. That's some of those base scratch images. They define, they download one of the Java versions, and this is Alpine whatever, Alpine 11, 270 megabytes, etc. And then they add Payara Micro in a layer, etc. And you see, you can nicely follow those things. And for instance, here you could then check what was changed. There is some in that EDC file here, and then you could see what is exactly changed, etc. So you can have a nice overview. You can have also a look into those Docker images. And then you see there is, the total size is 358 megabytes, and there is only 175 kilobyte wasted space. So things that are overwritten and no longer have. So an efficiency of 99% is, of course, very, very, very good. It's probably very difficult to achieve 100%. So especially that tool here, Dive, is a very nice one if you want to have a deeper look into your images. I don't see any questions in the meantime, so I propose a 10 minutes break, and then we are going to use those Docker images with integration testing, so that you can test your application, so that you might maybe implement a continuous deployment, so that every commit is results in a push to production, if you like. I'll see you in 10 minutes. So we are back for the last hour or something with integration testing, which is, of course, important. And yeah, integration testing in general is more challenging than a pure unit testing. You all know that, because you have all those different components that need to work together. And when you have a microservice environment, then again, that is another level of complexity, because you have then other services that probably will be called as part of a process of a request. So you all need to somehow match them, somehow configure them, somehow make sure that you test what you want to test, your application. And test containers works on top of Docker. And the idea is that your application is then deployed as within a Docker container, and also your dependencies. So you can quickly start up, relatively quickly, of course. You can start up a database, for example. You can populate that with a fixed set of data for that specific test. You can run that. You can test your endpoint. You can see if it's with that fixed set of data that you that well-defined set of data, see if it's returns what it should return. And then, yeah, at the end of the test, you can basically drop everything and do something else, your application again with a database with another set of data, or an even other microservice, etc. So your consistency of your tests will greatly improve your repeatability, because you have that container environment where you can relatively easily set something up in a well-known state, so that your test runs always against the same values, and which is much more difficult if you don't have test containers and you have, for instance, a database which is used for testing there, but people change things, test data are not the same the day after, etc. And that can be a nightmare. And I show you first the basic way and how we can do it, and then I point you to let's say the advanced version that I created before the summer, to bring that integration testing to the next level for Jakarta EE. Yeah, the Docker images they have. I forgot to mention there is a third Maven plugin, the JIP, the Java image builder Maven plugin, which you can also use. But at the time that I created this one, I didn't play with that already, but that's also an option. But now those test containers, integration tests. And yeah, I'm testing that application that you have seen before, which I used for MicroStream with the CDI integration. I want to put that under test to see if I call those endpoints, if my data is stored, if I call that endpoint to call data again, if that is updated, etc. That's, of course, a minimalistic test, but it shows that you can do those kind of global testing, integration testing. Which means that I need to add a set of test dependencies, quite a set of dependencies. I need JUnit 5, so I'm using JUnit 5. For my assertions, I like to use assert.j because they have nice fluent testings and some nice abstractions and readable tests. So that's why I'm using assert.j. That's personal opinion. But then I'm using test containers, of course, and test containers is a bit test framework independent. You can use it with many things, not only JUnit. So that's why you need a JUnit integration for so that you have an integration between test containers and JUnit 5, which is added here. And these things are actually my extension. So I come to that in a moment. What it is. No, this one is, so this is an example of using pure test containers as it is. It is more or less a framework. So you can build things on top of it, which I will do in the next step. The first level, and then, as I said, the next level, I will point you where you can find it. So yeah, you annotate your test itself, your integration test, so it ends on IT by default. You annotate it with an JUnit 5 extension. So that's that extension can look for for fields that are annotated with container, which represent a container. That can be a predefined container like those databases, but it can be a generic container where you define that it runs on Payara Micro, that your application runs with Payara Micro in that generic container. So I'm using that from name, that from 5.2022.4 JDK11 image. I copy my file within that container, and that file that I copy is the WAR file. So I'm referencing that through that mountable file. That's something from test containers, and I copy that to this location. So I'm internal within the container. It's called app and no longer my service, but I'm trying to keep it generic, and I specify that there is a context root called / so that means that this name of my WAR file is not part of the URL. To have a bit faster startup, I say that there is no clustering requirement, so that Payara Micro does not start up Hazelcast. And I deploy my app.war file that I've copied there. That startup, that takes a bit of time. That's more than those 5 seconds on because it's now in a container. That's I have assigned my Docker host here not all my resources, because I don't want that one of my containers steal all my CPU and that I'm basically locked out of my own machine. So it takes more time because I only assigned it a few CPUs, so it takes more time. So test containers need to know when your container is ready, and it's also using it can be using those health endpoints. Remember, health endpoint, basic health endpoint for Payara Micro. If your application is up and running and everything is fine, it reports status 200 with value up, and that is something that you can configure here as a part of the configuration, so that test containers knows that this container is ready and it can start your first test. Because you can have multiple containers that can be started in parallel. That's one thing. Remember, MicroProfile, REST client. I'm combining almost everything that we have seen in this example here, where you have an interface that describes your endpoints. I'm using that to make my tests a bit more fluent, more easier to read. I'm just saying service get all. I should rename that to get all products. So that's easier, so that I ask through that call, I do a remote call to my application which is running within my container, get me all the products. So that's a nice way of abstracting it, but how can I say where my container is running, where my app is running? So that's the reason why I have this before step, that setup step. MicroProfile REST client, you remember that you can inject based on that qualifier with that REST client, but you can also use it programmatically. You can say a builder, and this is my base URI, which was earlier today, which was in that MicroProfile config file. Now I'm setting it programmatically, and I'm saying that I need to create a client, a proxy for this interface. And on the fly, I also register JSON support. And this base URI, it is running localhost because your Docker client is mapping it to localhost, but the port is randomly assigned by test containers. Why randomly? Well, if you have two, or you start Payara Micro twice, then yeah, they would twice use the same port 8080, which will clash nicely and it fails. So that's why it assigns it randomly, and test containers knows, of course, which container it's assigned to which port. So you can ask your container, which is here a class from test containers. You can ask which port do you have assigned on port 8080, and he has kept that info because I explicitly said that that I want to expose that port here. So once I have this service, now that I have this service, I have a proxy for my endpoints within my application. That's quite easy to do. You see, 2 lines, well, yeah, here 4 statements. This REST client builder, I need that now within my test, on my client side. So I need to include that in my dependencies, and that's this one. So the Apache CXF has a artifact ID that implements that MicroProfile client, and so I add it to the test. And this one, I'm adding the JAVAPRO JSON provider for JSON support within that MicroProfile client. Next thing is that probably I want to have a look at the log file what Payara Micro writes. Especially the first time, if you start with these kind of things, you make a few mistakes and yeah, your container does not start, but I need to see then the log files of the container. That is done by these 2 lines. Test containers provides what's called a log consumer, which pushes that to SLF4J. And that means that I can follow the output of my container, push that through SLF4J, and that SLF4J is then outputs is only an API, as you know. I'm using logback, where I have then here my configuration for logback, so that it outputs information, or I can change my levels whatever I want. Question from Christian: is it required to build the REST client before every test execution, or would a single instance also fit? Yeah, it's a single, this container is only created once for the entire class. So yes, it would be enough to build it once, but since I only have one test, it also makes no difference here. But yes, you're right. I should do this setup only once and not for each test. That's correctly. So if I have all the products, I insert the product again through my API. I ask again all the products, and I check if that product that I receive back is actually the same product that I did submit here. So I'm testing 3 calls here. With this integration testing, there is not always a possibility to have one test for one single functionality. You see, I need to call actually 3 endpoints. So yeah, some people say, oh, you can only test one thing in one test method, but that's not always possible within integration testing. So I can run this, and let me open my dashboard, and then you will see appear actually 2 containers appear. There is this container, which keeps an eye on the actual container, so that your container, in case something fails, that it gets nicely cleaned up, so that you don't end up with 100 containers at the end, because all things fails. And it's nicely done, and test is green. And another thing what I have as a side effect is that I have here my output of Payara Micro from within that container, because I showed there, I said that I need to follow the output, so I can follow all those things here. In case it goes wrong, that's of course easy to do. Okay, that works. But yeah, this is a lot of repetitive code. You need, okay, you can split it out, abstract test class, but a few things are not that easy. I've found from the beginning that this should be more easily to do. So that was step one, where I actually create, based on the generic container, I create a Payara Micro container. I create my own container specialized for Payara Micro, where I assign, where I put that mountable file again, so I can reuse this. And the nice thing is, I can also have something for remote debugging, which makes testing, of course, a lot easier. So if I add the flag debug, then I add another port 5005, where I just start my JVM in debug mode, where I say suspend. So that means that my JVM starts up and it waits until I get a connection to that port. And I increase then my startup time, that test containers will wait at the maximum to 60 seconds, so that I have a bit more time to connect my remote debugger, and then the rest continues, and that I'm not having out of a timeout because my container took too long to start, because there is by default a timeout, startup timeout, I think of 15 seconds or 30 seconds, something used by test containers. So I can now already more simplify my my test, and I can add something which is really nice. I can use debug mode. I'm putting here debug through, and I just say Payara Micro container with my WAR file. This is still the same, and my test is still the same. I should have a unnamed, yes, I have an unnamed, and I should have a breakpoint here on the save. So everything is in place. So if I start this one now, then it starts up. And then it is waiting. So then I have some time to connect my remote debugger. It is connected. And now my Payara Micro starts. My test starts, and if everything goes well, then around 10 seconds later, my IDE gets control again, because that breakpoint is hit. Always something special. Is it going to stop? Yes or no? And yes, he does it again. My breakpoint is here. I can see which product, which item I have. I can follow the flow step by step. I can do whatever you normally do with breakpoints and remote debugging. Good. That's the first level, the first step to make things easier. the next level is that also this kind is no longer needed, that you can hide that, because yeah, that's always copy and paste. Again, you can put it somewhere, and that's the reason why I created this one, and it's called the Jakarta integration testing. And I have a document there, so then your test becomes even simpler. Where is it? Oh, by the way, it supports Payara Micro, Open Liberty, Wildflower, and Glassfish at the same time. More pages, please. Yes. You have just one dependency to add, so no longer those 5 or 6. It's already easier. And yeah, on your test class, you say that you extend that abstract class that I have defined, and then you define also which runtime you want to support. Payara Micro is one of them, of course. And you again create that interface just as before, but you can then just say inject me that with that REST client, and it is on purpose now lowercase and not uppercase because it is a specific annotation that I created. And you can define version numbers, which version of Payara Micro must run. You can even define custom build script files. The other thing that you can do is using wire mock. You can say wire mock, and so that you can mock dependencies for your microservices that your application might call, and that you have a mocking that you say, if that URL is called, then respond with a certain class or a certain JSON and just a certain string. So then you have full control over all those things. So that's the next level, I guess the final level that you can achieve, and that's the Jakarta integration testing. Have a look if you are interested in that. And by any chance, if you see something or if you have an idea of even improving it more, I still have my own ideas, like setting up a database where you read data from an Excel file, for example, or a CSV file, so that you have fixed data at a certain test. That's already in the pipeline, but please feel free to give me feedback and make your life easier, and then I'm happy to help you with that. So that's integration testing. Essential. Of course, do also unit testing. I have a presentation about that. It's not yet online, but I have given a presentation around testing in general with the Jakarta EE. So you can have unit testing with JUnit, welds integration. So only the on the weld level, on the CDI level, you have then things like this. On the integration level, where you can deploy your entire application and even do remote debugging and all those mocking and configuration, so that hopefully it makes testing a little bit easier. Any other question? Yeah, there was already one comment. Any questions about testing? Or maybe those that are interested in Jakarta EE integration testing. I've put the link in the chat. So Then there was a question yesterday. Not sure if that person is has joined today, but can you tell a bit about how to use Payara Micro with GMS queues in general, queue systems? Because yeah, that as I've shown in one of those diagrams. For instance, if you have a change that's probably within your microservice environment that needs to be propagated to other microservices for caching reasons, etc. So can you give an example? I have looked up a few things earlier today. I did not get to finish a real working example, but okay, let's try to give you already as much as possible, all the info possible that I have gathered at this moment. So Payara Micro has support for what's called GMS clients. So full GMS support means that you also need to have support for queues yourself. So your server needs to have the ability to have queues where you can put things and read things. That's not possible with Payara Micro, but Payara Micro has support for what's called the GMS clients, so that you can put something on a queue which is hosted on a remote server, on a remote service. ActiveMQ, for example, or there are several ones. And actually, that looks quite similar than the database access, because your application connects to the database through that JDBC driver. Here, your queue system, and I was a bit quick, I just have put the database cylinder on its side, and I said that it was a queue. You can connect to that queue with what is called a Java connection architecture connector. Difficult name. That acts as a JDBC driver. So within the app, you are using some generic way of interacting with an external system from that type, and there is a translation level at, like the JDBC driver translation level, that actually converts that to, for instance, ActiveQ. But Payara Micro, well, the guys from Payara itself have created a connector that follows this standard, but connects to Kafka, for example. So there are two blocks around it. So one is here, connect Payara Micro to an external JMS broker by deploying a resource adapter file. This is the OpenMQ, so that's the one from Glassfish. But there is also the ActiveQ one. And there is a link here to an application, but I'm not really satisfied about this application, because if you look in the POM file what it is using, then it is pure using the ActiveMQ dependency. It's not even using standard Java EE or Jakarta EE dependencies. So this is not really the independent way. So I tried to do on my own. I started with ActiveMQ Artemis, because that sounds the most simplest one to get started within Docker. That worked fine. I could create a queue manually there. That's also worked fine, but you need to, and that's mentioned here, you need to deploy then in your next step. Let's switch to the ActiveMQ one here. You need to deploy that specific archive file. So it's not a web archive file, but a resource adapter file for ActiveMQ. So I tried to use that one for ActiveMQ Artemis, and there seems to be something wrong with it because there is missing a XML file, which means that I get an error saying that there is no active GMS unit found. But the idea is then that you deploy your application. This is not through that at libs, but you deploy actually a second tab application and they are deployed in order. So your WAR file can make use of this RAR resource file. And then with some configuration, again, here with here hard-coded, but you can use those MicroProfile config parts for that. You could define where your server is listening, what your queue name is, etc. So that is the general idea. But as I said, I tried something like 2-3 hours this afternoon, and it was not working yet. So I would have need more time to make this and working. But that's the idea. The second example here is using that specific adapter for Apache Kafka. Again, setting up Kafka is not something that you do in 5 minutes. So that was also too long to get started, but this should give you a good idea how you get started with those. So I'm going to put those two references here in the chat. Using GMS, I'm going to put using ActiveMQ with Payara Micro. That's that link. And this is the using Kafka with Payara Micro. So these resources should give you a start on connecting Payara Micro with those two systems. But it's even a bit more complex than a database. I used to have to work with a database, so I could not fix it all those setups in the time that I had today, those 2 hours. That's about it, what I have for this training. I did see that there were a few people that joined later this morning, so I'm going to paste that link to that forum here if you want to have a certificate of attendance. So if you want that, then please fill in this forum. And I would say if you have any kind of question now, then that would be nice. Then I can cover it today. If not, you can always find me on these places. So that's, that is the GitHub repo where I put everything around that enterprise. For example, the Jakarta EE integration testing is there. My company, actually, the name is Adbash, so that's the reason why it's that name. I have put here my email address, Twitter and Mastodon handles. So if you want to reach me, question now, or if you have later a question, or if you say I want to have some kind of additional training, want to have some help with a certain issue, you can always contact me, and then we can find out how we can help each other with the problems. So if not, then hopefully you learned a few things. I saw already from nice feedback, so thank you for that. And I hope that you learned indeed a few things and that you can have a look at all that material that I have presented these 2 days. And as said, links to the recording will be sent out later. Okay, thank you and enjoy the rest of the evening. If you have still an evening, enjoy the rest of the week, the month, and next year.